Hello. There we go. Wait. This is not correct. Hang on. Hello, Blue. How's it going? Long time no see here. I've been busy, so couldn't stream for a while. Let's see. I'm trying to fix my audio here. Okay, there we go. Now it's back to normal, I think. Cool, cool. Can you hear me good? How are you doing, Blue? Move away all the things. All right. Okay. So, 1 second here. So, okay. We'll get started in a second here. I just need to prepare something here. Sorry. We're gonna get to some game development here. I'm just going to fix a thing here. You can listen to a keyboard in the meantime. Yeah, so I'm gonna explain here in a second. I've been I can say this. I've been vibe coding a lot. More like, well, I guess vibe coding is, I don't really not understand the term. I haven't looked it up or anything, but basically I would call it more like, well, unless this is what it means, but it's basically like AI assisted, heavily AI assisted programming. So I think yeah, that's gonna be like, it has gotten so good, which I'm super impressed by, that you can actually use AI as like assistant to a bunch of different things, and coding is like one of the things where it actually does a pretty good job. Like, yeah. So using that as a tool to actually increase productivity has been, I think it's important to learn that skill right now if you're a developer, because it will be incredibly good. I think in the future as well, it's just gonna improve, and all the tooling around it and how we actually program. I think it's gonna change a lot. I mean, it's already changed my work flow. Like, I've been building all sorts of things just in this last week. So I just need to do a thing here. Let's see. 1 second. main and I should have done this before the stream, but I just wanted to start. Let me just check this. Okay, now I just need to do the thing. And check another thing. Wait. Oh. There we go. I think. Oh, okay. I need to wait a bit. Okay, well, let's just get rid of this in the meantime here. So, okay, so let's start here. Sorry for that. Let's just start here. So, yeah, so in the last couple of streams, I've been talking a lot about plan for the first kind of, I'm not sure what to call it, like pre-alpha demo. Just to give it some kind of label, I guess. And we've done a lot of things that should be in here. Most of the things now are gonna be in this area, this forest area. So I wanna focus on that. So the thing that's missing is basically I want to extend the levels a little bit so they are larger. Right now they feel like very small and it takes like maximum 5 minutes to reach the boss. I'm not sure if that included actually beating the boss. I don't remember. But yeah, so I want to basically like double the time it takes to actually get to the boss, or have this kind of goal here. It takes 10 minutes to reach the boss if we're trying to just go directly to the boss. And speedrunning is not really the correct term here, because what I want to do also, I'm not gonna go ahead and try to explore things. I just want to go directly to the path to the boss, but also like kill monsters on the way. So I want to, so that's included in this here. But kill all speedrunning, but kill all monsters as well in the way. Yes, more gameplay content. So yeah, so there might not be that much coding actually in these coming streams. We'll see. The idea is that I will work in the editor mostly, and if I see something that I might wanna like improve in the editor, or some bug that we need to fix or something like that, then we can actually do some editor improvements, because I believe, I mean, yeah, we're gonna work in editor a lot, so there might be some things popping up there. But yeah, so I want to extend the scenes. Basically, yeah, as I've said here, taking 10 minutes to reach the boss. If we're we're taking the happy path to the boss, but we're killing all the monsters in the way. And then, yeah, make sure to add some secrets in like the areas and stuff, and monsters and stuff. Alright, so we're still missing Ancient Ghost graphics. The dungeon needs a lot of improvements. So this is just before the dungeon here, and then the actual dungeon. And dungeon basically starts where kind of the tree area is kind of starting. I want to improve the tiles graphics for the 3 tiles because I think it looks horrible right now. I just want to improve that a little bit so it looks, coherent. And then I also made a new tile set for like dungeon typey, like more structured tile set instead of like naturistic like trees. I have like done some more like just human, or not human, but pixie made structures. And then puzzles, of course gonna try and include more of those. The upgrade room needs to be finished, and the gameplay of the boss is sort of finished. I mean, I'm gonna just cut it off here, and then also I need to improve implement graphics for the boss and the spawns, which is gonna be a huge task, I think. And then there's going to be a little bit, when you enter the room, there's going to be a little intro. And then when you kill the boss, there's going to be some sort of thing happening there, which I've not really thought about that much. I think it's going to be like an exit will open up to the other side and you have to exit there. Maybe you can make a system where more you kill monsters, stronger you get. Yeah, I've been thinking about a lot of different things regarding that. It's like, how it's sort of like that kind of system is more like an RPG where you get like experience, or I mean technically you do get drops from monsters, so you do technically get kind of stronger because you get the loot from them. But yeah, that is definitely, it's gonna have like a huge impact on the actual game. Whatever you choose to do there, like if you want to have like levels or anything else that happens when you kill the monsters, but yeah, definitely I've been thinking about that, and has skill systems. I've been dreaming about having different skills that you basically, it's more like an RPG, and you kill like hordes of monsters with different like effects and stuff. But yeah, we'll see what will happen. If you don't kill it, it will be hard to kill the boss. Oh, you were talking about okay, I should have read ahead there. Kill the monster, stronger you get, and if you don't kill it, it will be hard to kill the boss. Are you talking about all monsters, or because they're gonna like respawn? It's just gonna be like normal, monsters. Oh yeah, that just reminded me, actually, I need to figure out also the respawning of the monster. We probably don't have to think about it in this version, but definitely there's gonna be like, if you kill all the monsters in one screen and you transition to the next screen and then go back again, then those monsters should still be gone, but there should be a system where they actually respawn at some point. Like maybe you move 2 or 3 screens ahead or something, then they respawn or something like that. I don't know. Just so you can't like go back and forth and exploit farming or something like that. So the player can't directly speedrun the boss. So the thing that I'm talking about here is not really trying to mitigate speedrunning. People can do whatever they want with that, so I don't really pay attention to that right now. What I mean here is basically just for a benchmark. You want to play 10 minutes? Yeah, so basically what I'm talking about here is like a benchmark for me personally. How long does it take me? Because last time, the whole point is that I want it. The whole level feels small. Basically, I wanted to check how long does it take to actually reach the boss if you just go straight to the boss, but you kill all the monsters that's in your way while going to the boss. And that took like 5 minutes, and that felt way too small to me, so I'm thinking about just trying to extend all the levels, because I really felt like they were too small anyway. So the idea is just to extend the levels, have some sort of benchmark goal where I just try to reach the boss and I have to kill all the monsters. So if it took like 5 minutes, then you could say that. And if we wanted to take 10 minutes, let's say. By the way, I'm not sure if that included the actual boss fight as well. So, you know, I might need to extend it even more. But basically, I think the first pass I would just double the length of all the scenes, and or try to, like, in total double everything, and yeah, so that is basically the goal here, and that's gonna be pretty good actually, because then we have more places to put secrets and stuff like that. So yeah, that is gonna be pretty interesting actually, because you know, I'm not a seasoned level developer or anything like that. So it feels like whenever I do levels, it's just things that I've seen before, and I'm just trying to rehash it. And maybe you can ask someone to play the level, because you already know the path. Someone's new, just definitely take more time. Yeah. Definitely. I mean, I don't even know what's a good time benchmark for it is. It's just like I just feel I just know that the area is too small. So I wanted to just have some sort of benchmark so I can push the areas like to a larger, and then of course I'm gonna try to fix. I'm gonna try to have people like playtest and see what they feel. But I just know that it's too small right now. So I just wanted to set some kind of benchmark here for myself, so I could, you know, have a goal that I can actually test and see that I actually reached the goal. I know for a fact that I'm not gonna shrink it anyway. So, but yeah, yeah. So I think maybe like doubling the length is gonna be the goal for now. All right, and then once all that is done, we are pretty good actually. The only thing I have left here is like investigate if we could improve the dialogue, so that's not a huge thing. We have some bugs that I need to squash, but it's not gonna be super. They are not like, you know, super hard to fix. So that's gonna be pretty simple there. All right, let me just check here if this is done now, because I want to show a little project that I've been working on. But if I can. Okay, it seems to be done now. I'm not sure if I want to show it now or if I want to wait actually. But until it's like more mature. But it's basically, it's like a programming thing. And it's just a fun test. I might show it sometime, but yeah. Oh, what the hell? Let's just show it now. Let's see. So let me. Okay, so I can. Hang on. I can. Actually, I can create a new. Well, what happened? It just disappeared. Why did it resize the window? Alright, I'm just gonna resize it using my script, Zig script here. No, it didn't work. Okay, so I have to manually do this. Man. Computers. Oh, and of course, it's like 1 pixel. Okay, there we go. Now let's go over here. All right, so whoops. And for some reason, ever since I revamped my Wes term, which is the terminal application that I'm using to run these terminals, it has the config. I revamped the config for this. It has started to like lag a little bit when you type in stuff. I'm not sure what's happening there. Maybe it's something else, but actually it should be like this. Is it .com? And then it's like colon, something like this, I think. Yes. Alright, I'm just gonna start agent. There we go, so I don't have to type in that. Alright, so here's a thing called Runic, which is well, we can just go, to, whoop. Oh shit. Wait, I need to fix this. After this project, would you like to try Godot? I actually went ahead there, and I actually tried to make a little project in Godot. Just to get, you know, when actually, if I'm gonna stream it, I want to have, I don't want it to be like all the way from the start. I want to, because that's gonna be just me reading a whole bunch of stuff. But so I wanted to get some idea on how it works first, because it's a little bit different from what from other stuff that I've been using before. Wait. No. Where is this thing? It's gonna be here. Go. All right. Okay, so I made this new. So basically, I've been using Codex to program a new language in the last couple of days. It's just like, I don't know, 3 or 4 days or something. And I've been just heavily using Codex to like generate a whole bunch of stuff. It's written in SIG, and what it is basically a language that is big. Okay, so the reason that I created it was basically I didn't look up any alternatives or anything like that. I wanted to make my own language, and it's basically like a replacement for the Bash scripts, because I don't want to have to write a bunch of Bash scripts anymore. So I just made my own programming language called Runic. And yeah, this is all, by the way, this is all like AI generated README here. But I've basically been gone all the way, you could say, with AI in the last in the last week. And been building all sorts of different tools and stuff to try to improve my workflow, and this is one of the things that I wanted to do. Like, I just love building tools. Actually, I just found this. I just like building, tools to help me build more stuff. Procrastination could be called procrastination, but yeah. So Runic is like this scripting language that the idea is it would replace Bash, but it would also have like better syntax. If we look at, there's like features.md, so we don't really have like syntax highlighting in the markdown yet, but we could look at the tests here actually. Let's do test runic. Let me see here. This is gonna generate an error here, but basically you can just use it as a normal bash script like this. It doesn't have exact syntax as bash, but it's gonna be pretty close. So the idea is you wouldn't actually use bash with this, but you could use bash scripts, and the idea is it's gonna be like somewhat like compatible. I'm not exactly sure yet how I want to do this, but this works. So if I run this, I haven't set it up. Well, if I run, let's see, sig out. Actually, I have to build it first. It's written in sig, so that's the best part. So let's run the thing, runic. Wait, where is it? Oh, maybe I don't get auto completion here. So runic. Yeah, this will type out hello, of course. So this basically, if you just put a thing like this, if we just run the command as is. So this just runs echo command. You can run this command. It will just do this. One thing though, there's no like color support yet, but I'm just gonna ask AI to implement that, so that's no problem. No, but some things I have to do like manually, but it would be interesting also to do it. But yeah, but what you can also do, you can have variables like this. So you can say like greeting is a string, and it's hello, and then we can put the greeting in like this. So this will basically do this here. The breadcrumbs are working. The breadcrumbs. What breadcrumbs? Yeah. So hello world. Yeah. And you can have functions like this. You can have functions greet and put a greeting in here, and then echo this greeting. And so we will we will call this. Actually, I'm not sure if this will work now because there's like a bug in the program, but we'll see. Hello again. No. Okay, it didn't work. Yeah, but anyway, that's the idea of the thing. And so it's gonna be like bash, but it's like type safe. So you're gonna have strings, you can have floats, integers, and arrays, like sanely, I guess you could say. You don't okay, so basically it's like, sure, it's got its own syntax. I'll try to actually make the syntax look like Zig. So actually, you know, as I showed before, like you can have like a result is a struct that has value, is a nullable. Also there's like the optionals like this, and then if it's okay. So basically this looks like Zig, right? Because you have the binding here, it's a type, it's capital letters. You have the struct here, and that's a type. So you bind this to a type. Now this doesn't actually work in the current version, but I'm gonna make it work. And so and yeah, so now we have the result type, which is this kind of struct here. I also plan to have the so let's say you have this result, or yeah. So let's say so actually this is kind of like, I mean, this whole result type is basically just like an optional actually. But let's say we have this. So let's say you have like this optional, here's an optional float or something, and we say null. So just as with Zig, you're gonna be able to capture this. So I really like this syntax. So basically, I'm building like a Zig syntax bash scripting language. so just to have it, because I just don't like the syntax in bash, and everything feels like every time you want to do something, it feels like it has a special syntax just for that thing, and I can never like get it to stick in my head to actually, because I'm not sitting in bash all day and scripting in that. So I would rather have Zig syntax, and then make a language that can actually work with that, and also have commands that you can actually just call like this. And also another cool thing, well, I'm just gonna do this here, so you can do that. And then also another thing is that you can actually get the process out like this. So now this is kind of like the process, because every time you run a command, you don't just get like one result, you get like 3 different results. You get like the standard out, the standard error, and the exit code. So when you do this is actually all 3 of them combined. And then you can like if on it, if echo process, and then I haven't really decided on how actually to like capture it. But you can destruct. The idea is that you could destructure it as well. So you could or deconstruct it. You could get like std out like this, echo out, echo and then I think it's like status or something like that, exit code, or I don't remember. But basically you can deconstruct it like this, and then you can use the other things as well. And then I had like special syntax for that as well, so it's like a little bit easier to work with. And then you can also run, the idea is you're gonna be able to run it like asynchronously by this, and this is the same syntax as bash, so you can run it async. And then if you have this async, you can also like implicitly wait for it like this, and you get like the result out here if you want to do it like this. So that's the idea. I haven't really thought about every little detail here, but I just know that I want to have something, and AI is actually helping me build this insanely quickly. So yeah, so a lot of these things doesn't work yet, but I'm gonna just have AI work on this in the background. I'm gonna test it. So we actually have a couple tests that work right now. So if I go to like here, so this all works. Also, oh yeah, I forgot to mention, there's like you can import modules like this, but I'm gonna change the syntax to be more like Zig, because right now I'm implementing structs. So instead of having this syntax, I'm gonna like let ensure equal and then import test support ensure, and then possibly even do this, because then you get like full type, or you can actually like jump to the file or something like that through the editors, and then import, and then, because then the thing is now that this is like a special kind of statement, so you can't really do much with it. This, however, becomes like an expression that imports the thing and then produces the struct that it has. And so that's why I want to implement structs right now, because this will actually produce like a struct type that is the file, and then I can actually access things on it like this. So that's way better, I think, because then I can also use this as an expression anywhere. I don't have to have this special syntax for importing. So yeah, so but anyway, this works. This one should work, yes. test passed, so we get down here to do this. So what we have here is we have this import into an ensure module, and we also, this kind of weird, we're shadowing the module name because this is the module. I should rename this like module or something. It's gonna change, but yeah, this should still work here. So we're basically binding to, just like a Zig, you can bind anything to a function. It will basically become an alias for that function. And then we have this pipeline. So this all works here. This is the process, and you can check the status is okay. And then you can also get the standard out from that. So this works, and it's pretty cool actually. But I think in order to build more meaningful programs with this, like scripts, I need more features. But yeah, already this is kind of cool to me. Like you can, you know, already do this pipe stuff, and you can check the status and get the standard out and everything. So yeah, that's pretty cool. And yeah, and this is all like I haven't touched the Zig code for this, unless there are like build problems, because the AI actually used like an older version of Zig, so I had to manually go in and update everything to 0.15. But it wasn't a huge amount of stuff. It was just like array list. They were using like the unmanaged versions of array list, and then assuming that it was called array list, but now since Zig has changed that, now that broke, and some other stuff as well. But yeah, this is all of the groundwork. Everything is AI generated. Yeah, we have this. You can have like expressions like this without having to run some, you know, weird bash command to actually do an expression. So it's kind of like the programming language. It's like a normal programming language, but it's also mixed in with, you can just spawn commands just by typing the commands out like this. So that's kind of what it is. All right, enough about this. So I've basically been, you know, I'm just gonna see if this works here. I have this smoke test series of things that I'm constantly testing here to see that it still works. This should also work. You can have like arrays and objects like this. This would basically be like a anonymous struct, I guess. And the syntax right now is like a JSON syntax, but I'm pretty sure I want to change everything like this to be more like Zig, so we get consistent syntax. And yeah, array indexing and everything there. Let me just check here. What was not working? This actually works, everything here. I was surprised here that the map actually works here. This is probably like hard coded, because we don't really have, yeah, this is hard coded because we're not importing anything at this type here. So we don't really have like you know, type variables or, you know, anything like that. But yeah. But anyway, so yeah, that's just what I wanted to show what I've been working on, and hopefully this will be pretty cool. All right, so let's see. I had something that I wanted to fix, and that was the struct stuff. So I'm just gonna do this, and well, let's have this result here. If we actually run this, there's gonna be an error, invalid let binding, invalid type expression. So what I do then is I can select this code, and I can I can actually send this into Codex directly, because I built this plugin for NeoVim. Well, plugin, but like a script in NeoVim that I can select some code, and I can have that as a context when prompting Codex here. So I can say like runic command reports a what was it? I have to check now. Invalid type expression. Okay. So runic command reports a invalid type expression error here. Try to fix this in the runic source code so we can support this kind of type expression. All right, and then it's gonna go ahead and run that, and then we can oh, I see. I have to actually enable codecs to work in this repository first. Okay, now we can. What's cool also is that NeoVim actually has like auto. Well, it remembers the history of this command, so I can just press up and I get the same command again if something went wrong. So I can just do that. So that's pretty cool. Okay, now it's gonna go ahead and start working on that. So I can tell it to do that, and then I can go over to the whatever I was working on here. So I just wanted to show that little bit there, and so very cool. Thank you, Blue. I just remember there was a name for a variable function, something like breadcrumbs in your code base. I could be wrong. Oh. Breadcrumbs. Yeah, I don't. Oh yeah, maybe. Oh yeah, I think that was the homepage. The homepage had breadcrumbs. Yeah, that's right. All right. Okay. Actually, I also made a. Oh, it doesn't work. No, why is that? Oh yeah, because I haven't. Oh yeah, but also a huge revelation there is that the AI is actually pretty good at doing Zig, which I was super surprised. I mean, I guess Zig has been around for longer than I think, but I mean, it's good at generating Zig, but you have to. But it does use like an older version, so you have to sort of update some stuff. But it mostly works pretty well. I mean, it generates pretty reasonable code that works. I mean, all of that language has been generated by the AI basically, so it's pretty good. All right, let's see if we can get this running here. There we go. Okay, I've been toying around with this new. You can see here, this is like the new, just kind of dungeon tile stuff. So this is kind of like the entrance to the dungeon. So I wanted to have some sort of, changing scenery for that. But yeah. Okay, so where should we begin? So I'm thinking I want to start with extending the map a bit. I'm not gonna touch this part. I think I'm just gonna remove this altogether. Maybe we'll see, but because we're not gonna go any further here anyway. But yeah, things like this part, everything here, I'm gonna basically double in length. Is the idea. Yeah. I mean, if you look at this one, this is super small. It's just this little screen here. This feels like so, I don't know, unnecessary to be this small. It should just be larger there. AI can do new file system. No, it can't. That's also the thing. It couldn't do it. So I had to manually fix all of those. But luckily, there wasn't a huge much of them. So, but yeah, you have to actually fix that yourself. However, what you can do, which I did as well, and it got a little tiny bit better after that, was that I downloaded the entire standard library documentation, I think it was, into because it's available on some sort of Git repo. So I just cloned that down and put it in the repo, and just told AI through the agents.md file, which all agents basically. Well, the idea is that all agents are gonna read that file to get some like information about the project and what to do and stuff. In each task, so you don't have to type that yourself. I think it's basically just pastes that into the prompt or something. But yeah, so what am I gonna say? Yeah. So I basically just cloned the whole documentation into the repo so that Codex has, you know, a local version of that, because I don't. What you also could do is you could enable like internet access in Codex, but I didn't do that because then they warn that there's like a security risk. Like if someone hacks into their system, they can actually get like full access to my computer, because that's how it works. Like it has like full access to some of my computer, so it could get things like secrets, like Codex. Well, I guess maybe not secrets. Well, I guess it could read the .n file in the repo. But yeah, anyway. So or maybe even do other stuff like trying to get access some other way. So basically everything that you have to. It can't Google and stuff like that. So unless you actually, maybe you can give it tools in your local computer to actually Google some stuff. Maybe you could do that, maybe. But because you can't tell it to use different tools. Like you can't tell it to use like different executables. Like run this command and fix the errors that it produces or something like that. So it will be able to do that. But it is running in like a more constrained environment, so it can't do everything that you can, especially outside of the repo fold directory. So yeah, it doesn't work flawlessly, I guess, but yeah, it's for security, so it's not able to do anything like everything. All right, so. Man, what I was thinking. Yeah. So you put the whole documentation in the repo, because then it can get access to that repo and documentation. And then I also tell it in the agents.md file that it could look in there to actually see how the syntax works, because there has been updates to the syntax. So it does that. And that's kind of a thread in like using Codex and those agents like that. Is that if they don't have like internet access to check the latest versions or the current version that you're using documentation for that specific version, then they're just gonna make up some whatever version they knew about, and that can be. It's actually impressive how much it can do by itself, but it is outdated, and sometimes it's just plain wrong as well. So. But yeah, that's the things that you have to, as a programmer, go in and fix yourself. So, but yeah. Okay, so let's see. Oh yeah, and this whole area is not even. I never even started on that. So, but that's kind of like a side area, like this down here. I'm just gonna focus on the main path right now, like basically all the way to the boss. I'm not gonna think about anything else. So yeah, let's start over here. And I do have a couple of tools to, I guess, more easily do things here. So if I, for example, go in here and I want to double this size, I can just, there's no multi-select, so I have to select every. Oh, I can actually only. Okay, that's gonna be a bit. Okay, anyway, let's just. Yeah, okay, so that didn't work. I think I actually have to like exit and restart, because. Okay, so it's kind of complicated why I couldn't do that. I need to actually leave a hole open here. Copy paste. let's have focus on, so we can see which one we're dealing with. And now, since I can only select, I can only click inside here, because that's how it works. I have to click here, because you have to click outside to actually do the paste. And it also disappeared because that's not supposed. So I have to fix this here. Or I can also go back, undo everything. I can go to tile paint mode. I can select foreground. I can do that. And I can draw a line over here. So, oh, it was straight. That was pretty lucky. Now I can go, but I don't want to copy this house though. I just want to copy like everything else. So we'll start with the foreground. And let's move this over here. Alright, so I basically copied the length of this, but I probably want to like change it a little bit. And we'll remove this. Also, there's no easy way to actually like lower the size, or I mean shrink from the left side here. So I'm just gonna do that. Fill this in here. Copy this part over there. And copy. Actually, we'll copy this part there. Why is that? Okay. Think like this. Okay. There we go. So now we have that. It's just copied, but I'm gonna change it a little bit. Alright, so let's save that. Was there anything else? There was the background too as well, like these things here. Man, they are all the same. I guess that's fine. I can take that, and I can just move it over here. Wait, where would it be? There? I'm confused. That should end up there. Oh, that's okay. I see. This is the house part. There we go. Okay. There we go. So now that we've done this, I'm just gonna go back to the scene. And you can see now every entity is still like in the correct position. We resize the tile map. They keep the original position. But we need to move these things. The entrance and the exit over here. Oops. How did that was there over and behind? Okay. There we go. All right. Actually, is that how it is? I think it's like 1 over. Whatever. Let's just do that. Okay, and then I wanna take the player and start. Let's start over here. And can I move here now? Yes. Yeah. Okay. So I need this to be like. Well, maybe I could just do this. Wait, you can't actually. I can't actually do that. Okay. So I think maybe that's because it's a special type of entity, actually. Okay, now it works. Cool. Oh, the door. The door has the wrong graphics. I need to fix that. Okay. Okay. Well, this was actually convenient that I can just do this, but also a bit annoying that it doesn't work. Cool. Now is this like too large now? I don't know. Let's put. I guess we'll put some other monsters here, so it's not like too monotonous here. Let's put like one of. Here we could put one of you, these guys. And it's like the first screen, so it's gonna have to be, you know, easy mode. So maybe we actually remove some of these, like these. This guy here. Oops. Okay, here can I add 2 of these. That's fine. All right. Okay, I'm just gonna test this now. Yeah, definitely feels more like a starting area now where there's like barely any enemies. Get to take it a little bit easier. Maybe we'll actually move this house. Not sure. Oh yeah, these guys. Actually, I'll remove these guys. They are so buggy now anyway. I have to. Oh yeah, that's also one thing that I have to fix. Whoops. Where is that guy? This guy. I'll remove that, and I have to also. So let's save. And we'll go to the notes. Bugs, battling super weird. That's a bug description. Alright, let's see how the AI is doing here. Okay, so it's done. Update the script line. Agree to keep reading. Yeah, I barely read this. I just see if it you know, works. Let's do like result. I'm not sure how it wants me to do this. I'll just use like JSON here. I don't think you can actually echo the actual result out. Invalid let binding, invalid object literal. So this is the next part then. So so we'll do like run report invalid invalid let binding on this here. Try to fix in the running source code. So this is basically the workflow. Basically, it's you tell AI to do something, you go and check what it's done, then you do progress a little bit more. Now we're gonna fix the next thing. You tell it to fix that. It's gonna run. I'm gonna come back, and it's gonna, you know, that's kind of what I've been doing now for last couple of days, only with this programming language. And you know, the progress is, I mean, to get this far would have taken so much time otherwise. But yeah, I do feel like it was more better in the start. It took way less time to do stuff, but now it's like it's starting to get more and more complicated and take more and more time to do things. So yeah, we'll see how much it can. And sometimes when it like fixes one thing, it breaks something else. So it's not perfect, you know. But yeah, we'll get there. Try to fix real source code so that we can support this type of expression in a let binding. Alright, it will work on that there, and hopefully in the end we'll have a really nice language. Also the syntax, whoops. The syntax highlighting everything is also like AI generated. In this is only for Vim right now, but I also plan to implement an LSP using the AI for this. So that's gonna be interesting because you can, like, you know, you can see what type stuff is, and you know, get diagnostics directly here for type checks and other stuff. So that's gonna be pretty cool. Another thing that's gonna be pretty cool is actually getting like a typed result out of these commands. Like, let's say you want to, well, echo is basically just gonna echo like as you get a string or something. But let's say you wanna take the output of listing the files, for example, and then you map that to a type in this language. Then you're all of a sudden gonna have a typed ls command, and it could depend on the type, like I guess it could depend on like the flags and stuff, but yeah, that's gonna be pretty interesting to see if we could do anything with that. But that's good. That would be super cool. But basically, first and foremost, it's just gonna be like a nice way of writing these kinds of scripts where you just want to execute a bunch of commands. You want to use the input from one, put it into output of the other, blah 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 blah. So yeah, that's gonna be pretty cool. Okay, let's see. Where are we here? Alright, so I wanna replay this and test this a little bit. Maybe I'll just extend everything first, and then afterwards just we'll do like iterative process. I'm not sure what the best approach is, to be honest. Also the text boxes needs a revamp. Oh, I forgot about that. Yeah, I should really put that in the to-do list. This area feels a bit like empty, so might want to do something with that. And there's really no reason to like jump up here. You could just go down because that's the easier path. It's just a different path. And here's like, oh, it's another enemy. I can't hurt it. Oh. But I can if I attack it while it's attacking me. Alright. And now it's basically just repeated here. Okay, so it wasn't too bad. I think this is a good length, actually. I was thinking like maybe this is too long here, but I don't think so, actually. This is a pretty good length. All right. Cool, but I do want to add some stuff, like maybe some kind of... The problem with the secrets is that basically right now the only thing I have is like chests. Okay, but I was promising myself that I shouldn't think too much about that. Maybe over here we could like jump up a little bit to get to some kind of secret or something. Like, yeah, you just jump up and then there's like more up here. So we can take this guy. Actually, to increase, we have to sort of paint up here. So how far up will we go? So now this is... I'm just counting how far up this is. Here, this... I think it's like 3. Yeah, 3 you can jump up. 3 to the roof, to the ceiling. Yeah. And then let's increase this a little bit more. Maybe I should not even have a boundary, to be honest. Like maybe, well, yeah, I guess maybe it's good to see where the boundary is. I don't know. Alright, let's have like smaller. Yeah, we'll have smaller platforms. Can you make that jump? And then, or maybe it should be over here because you want to progress, right? Actually, let's copy this. And then I'll put a sort of helper thing down here so that we can know that, okay, it's safe to kind of jump down, I guess. Could also act as a you know, if you skip this part, you go over here and you see, oh, there's something up here. So then you know that, okay, maybe I can go back and get there. Okay. Let's go back here and we'll move the player. Let's see if we can actually make this jump here. Yes. Okay, that's very cool. But we should put some sort of, I guess, challenge here then. Why is the camera like shaking like that when I jump? I think it's probably to do with the snapping thing, maybe. Oh, why are you stuck? Oh no, it's falling apart. But yeah, you can make this jump easily here. Yeah. All right, and then we should put some. Probably should put some like. Some type of monster here. And maybe extend this. And I don't want to get it too far because then you're just gonna. Also, this goes down to this guy. Maybe we'll move all this a little bit to the right. Yeah, like that. Actually, could you make this jump now? This kind of lures you down straight to the monster, so maybe we can do like maybe we could do like a wall. No. I'll extend that a little bit so that you don't like get to the ceiling. Okay, so we jump here, jump that. That's that part. Maybe we could do this. I'll extend this a little bit. And then put some monster there. Yeah, I'll just do this. Maybe. I'm not sure how to do descent here. Do this descent. I don't want to create a path up here. Or maybe we'll make a path back down there or something like that. It's interesting. I've never actually had to think like this too much before. Like, okay, how can we like direct the player to go in a certain place? Fight some monster. Get down here, open the chest. You can't actually, well, okay, yeah, you can actually look around. I forgot about that. So you can look down and go down, okay. Alright, so what kind of monster do we put out here? Maybe one of you guys? and then there, and then a chest like over here, and I have to make sure you can't jump here. Alright, yeah, gems is fine. That one always gets me for some reason. You're like, oh, there's a chest up there. I wonder how you get there. Whoop. Okay, I'm gonna blame it on the controller. Something is weird with the camera. Whoa. Okay, this is part of the physics, the physics bug with these monsters. Of course, it just goes down. Maybe I should put like guardrails there. Whoa. Okay, I think the chest, yeah, it lagged a little bit. I think the chest, or a little bit, it lagged a lot. Chest should be open now because it's like saved, so I have to go and kill the save file. And let's also just start up here. I should probably extend this so you can't like fall down easily. Okay, this is interesting. Yeah. Why is this so laggy now? Because this was not the case before. What changed to get this laggy? Oh, hello, Zephlins. Welcome. There's a neat vibe we got going here. I kind of like it. Oh, thank you. Polygon system lag. So this is like, I think it's just these items here make it lag more. I think it's probably due to the changes to the collision system that I had. So if we go, yeah, I'm trying to execute the quadri here. So here's the quadri. You can see here that all of them are on a line here, which makes them, all of them be in this quadrant. If I go over here, will that, no. Yeah, so basically, the thing is, the collision system is not really, oh man, this is horrible right now. So the collision system, if I try to explain it here, well, now they're gone. So, but what I'm trying to say is that the collision system checks for collisions of all entities against each other every frame. Well, actually multiple times every frame, because there's like 4 or 8, I think it's 8 sub-steps in the physics system that checks for collisions. So if you add a bunch of entities in the same place, then all of them are gonna be like checked against each other, basically. Especially if they're on a line like that, they will all be like in the same container, so they have to like be brute force checked against each other. Now we could change the algorithm there to make them like make like a sweep, maybe like a sweep, use a sweep algorithm, like when you get further down. But yeah, I think the main issue is that we enable collision detection for everything against everything else. And then afterwards, I have this grouping feature where only things of a certain group can actually collide, like, resolve collisions between. So that's why I'm staying on this ground here, is because the player is in the player group, this is in the ground group, and since we have a system that has collision enabled between those groups, so that after we get all the collisions from the collision system, we then check which of those are going to be actually resolved to make them block each other. So maybe we want to change that. So basically the grouping system, the collision group system, only says that which ones are gonna block each other is basically what is saying here. But really, maybe we should actually have another system where we check, okay, where we like say that actually those are the only ones we need to check against, those that are from this group. However, I don't know if I have a good idea on how to actually do that. Because it's not like that is embedded in the quad tree. I mean, maybe we could build a quad tree for each group, but that would be a lot, I think. Collision layers. Yeah. Well, I think that's kind of what I'm thinking about here, is because we sort of have we okay. Let's see. Well, I have to go to the Zig to my game engine, and then we have like physics, and right. So here's the groups, and the groups. Well, as I explained, they are basically just, you have a bunch of groups. They are like string identified by a string, and you add entities to a specific group, and then the groups can be you can enable for a whole group, you enable collisions for another group, and so then you have a system where you can see that, okay, collisions are enabled for this specific thing, and then yeah, we have this resolve collision thing. So here's the whole physics update here. So so we have physics substeps. We update the positions. That is very fast. We update the collisions. Now this is the slow part. And that's where we check collisions against everything, and then we got a bunch of collision events, and then we resolve the collisions. And this part is the only part where the collision groups are taken into account. Substepping could be swapped out for swept axis aligned boundary box using raycasts. Okay. Interesting. Yeah, so the thing is, like, this game is not gonna have a million entities in the same scene. So it's basically, I think maximum, I don't know, a couple of hundred. Let's say the most upper limit would be like 1,000 entities in the same, and that's very, very huge for this kind of game. So because there's gonna be like projectiles, it's not a bullet hell game or anything like that. So the entities are basically never gonna, exceed the most of the entities are actually ground. They're ground, and so that's why you can get up to those kind of numbers, especially when we have, the larger scenes. Yeah, and the tiles, the ground is actually, those are all like, they should all be like axis aligned, whatever, squares. So potentially we could improve the system to use like these kind of tiles that are fixed and always in a square, always takes up the whole square, stuff like that. Right now I'm basically merging all the ground tiles into entities, so they are not like one entity per tile. It's more like each horizontal line is merged, as you can see here. Let's see if I can get a better example. If I go down here and enable my collision box, so this is like the entities, all the entities are surrounded by, you can see this is an entity, this is an entity, all the white lines, all the white boxes are one entity. So the ground is merged horizontally because that's usually the most effective way of merging one line of entities. So that's the ground tile. So basically all of them, all the lines are merged like this, and then so I'm actually working on something, merging any polygon tiles in a single mesh. Yeah, so the thing is like all the collision things are it's always an AABB. So I don't have any other shapes right now. I could implement that because the quad tree, it does have support for having a boundary box first that you put into the tree, and then have a more complicated shape that you would check against when you know that you're in the same quadrant. And so that could potentially work. The problem though, I guess also, is that the larger the shape is, the further up it's gonna get, I guess. I don't know. But oh, okay. But yeah, I think the main issue here is that we check. So basically ground does not need to be checked against other grounds. But we're still doing that. We're still checking everything against everything else. So yeah. So how would we fix that? So that the idea then is that in here, in update collisions, we would we're now using the quad tree. We're doing a I kind of have this weird quad tree here where the first substep I build it, subsequent substeps I do as another algorithm where I kind of, because the idea is that the entities in a substep probably hasn't moved that much. So I have a separate algorithm for subsequent substeps where I reinsert entities that needs to be reinserted, and then I do a check against again. So I don't have to rebuild the entire thing. I just have to like reinsert the ones that are no longer contained within their quadrant. Just because of the fact that in a substep you probably don't have that much velocity happening. So most of the entities are probably in the same place. Thing that already have collision is the locality of objects has spatial partitioning. Yeah, so I do have spatial partitioning in the form of a quad tree. And that's also what you can see here. So you can see when I enable, this is a collision system here. The blue line, the green line here is the root node, so that encapsulates everything. The blue line is I think the second layer of nodes. So those are the 4 blue lines are like, or 4 blue quadrants of the green one, and then you have red there as well. I think that's how it is. But anyway, the point is that you can see how it's like dynamically kind of changing here. But really, every frame, the whole quad tree is like built from the ground up. So, but it doesn't take long to actually build a tree. So, yeah. So that's the spatial partitioning. So it's not like I'm using brute force. I was saying like, if the brute force is actually applied when you get down to the last level. Yeah. I'm not actually doing dynamic updates though, so that's the thing. I'm not doing dynamic. I'm rebuilding the tree each frame. And well, okay, it's semi-true. I was trying to say here that I'm rebuilding the tree, the first substep in the physics system. I'm building the tree from scratch, and then subsequent substeps, because of the fact that the entities has probably not moved that much, I do a separate algorithm here that will, since entities are probably in the same quadrants, I can just reuse the same tree, but I will also check that each entity is still contained within their quadrant, and if they are, then I just do things as normal. If they aren't, I will reinsert the entity and then do the check. Yeah. But then the next frame I will just rebuild everything. But it's still the issue where we still check everything against everything else when we don't really need to. We should only check everything that is in the not the same group, but that has collision enabled for other entities. The problem is though, I'm not really sure how to do that efficiently. My first thought that was maybe we'll build a quad tree for each group, because then you can just check against each other group that you should be colliding for. Yeah, that could be a thing, but I'm not sure if that's gonna be too much. I mean, usually entities are only like in one group each. They could be in multiple groups. So yeah. So here, basically here we have a tree. We have one tree. We build it from scratch here. If we do a build and check algorithm. Otherwise we have a check algorithm where we update the positions and then do intersect check. But we still do it for everything against everything. Maybe we don't intersect at this point. Man. Do we need a quad tree for each group? I mean, I can just try it. I guess I can try to do that. That's gonna change a lot in here. But I can try to do that and then... but will that even do anything? Because those gems... I mean, yeah, we will skip like a lot of detections against... Okay, I want to try one thing though. I want to try one thing here. Let's see. Let's do... I want to just try and move this entire thing like down one. So let's move this down. And you down there. Okay. And then we'll put you over there. And I need to remove the save file. Okay, will it lag nearly as much now? Yes, it will actually. Okay, you can see here, now it's not on the line anymore, but they are still checking against each other, but it's only like 30 of them, so yeah, this is where I think if we change this, the last algorithm here to be a brute force, no, it is a brute force algorithm now. But if we change it to be a sweeping algorithm, then it might improve things a lot, I think. Let's try and do that instead. Also, I think I want to move this. This is a neat editor. Is it ImGui? Yes, it's ImGui. So I'll move this just... There we go. Actually, let's move it over there so we don't lose any gems. Okay. Let's try and do that. Because, yeah, as I said, we're using like quad tree as far as we can. But then the last part is actually done with a brute force. Oops. Wrong project. Here. Yeah, no problem. I love talking about it. It's nice when someone comes in and wants to chat a bit. Let's see. Have you done anything with Zig, by the way? I just want to check my also new projects. Here I have another project that I'm letting an AI do for me here. Let's see, what was this? I think I had this here. Invalid left binding. Do you work now is the question. No, you don't. Wait, this is leak. Unknown binding null. Oh. Okay, I'll just skip this null here and just do this. Oh, hey. Well, it kind of works. can I do this? Value, result of value. Oops. Yay! It works. Okay. Okay. So what next? Okay. So we can actually have structs now and do this. That's pretty cool. I do want to change the. I want to change so that it's like a zig type, like this instead. And then I can do this, and I can say change object literal expressions to be in this format instead. They should mimic the zig style struct instantiation syntax. Update the building source code to match this. Alright, there we go. Design for should pick up Zig or Rust next as a language to play with. Been enjoying Python a bunch. Time to dev space wicked. Okay, but I want something to with some fun high-level features, but fairly low and isn't bloated like C++. Oh, so you've done like C++ before? Python and C99 or C. Okay. A web dev a bit and ran away. Yeah, that requires dedication nowadays, like the web dev, and also like always keeping up to date. So yeah, with this as an example here, like AI tooling is now so good that I'm actually using like AI as a coworker to produce code for me while I'm doing other stuff. so it's like yeah, it has totally changed now. I think it's gonna change even more in the future, I think, with just because in this area, like the most important thing is like, well, one of the most important things if you're one who runs the company, I guess, is like results. And so so that this is gonna be like increasing productivity, I think, a whole bunch. We'll see how it goes in the future. It does struggle a bit with you know, it takes the larger the code base, the longer it takes for the AI to actually do things, but and do like correct things and stuff. But yeah. James Lansing cooked from our HTML Express EJS looks so fun to try those. Oh yeah. Yeah, so that maybe that's one part of it that's like a little bit less, you know, velocity in new things happening. All the browsers are continuously, you know, supporting newer things, but that's way less, I think, you know, changing than the landscape of being a web dev, like keeping up to all the latest, you know, frameworks and tools and everything. So going back like to HTMX and that stuff uses, you know, you're more close to the native like browser part and just native JS. So that could actually work for someone who wants to just dip into it a little bit. Just learning, because you're gonna have to learn the basics of HTML, CSS, and JavaScript anyways in order to be a web dev. So, or at least like a front end. But yeah. All right, let's let this cook here. Let's see. I'm doing this in the meantime here. So, where were we? Over here. I forgot now. Oh yeah. We want to do a sweep when we're deep down in the quad tree. So I already have a sweep algorithm. So I'm gonna try and reuse this. Here's sweep. Yeah, this is just a function here. Collision sweep. Yeah. So we have like source. Yeah, that's the rigid bodies. We have buffer is a sweep line. Oh, that's a buffer. Yeah, so we just provide a space for that. We have overlapping buffer. Yeah, so we're just providing space for this. We have the context, which we call which we supply to the function, the callback function for a intersection. So basically, yeah, that's all we need. And on axis overlap, that's a weird name. I want like on overlap. But I'm pretty sure this is like on collision or on intersection here. So I wanna try my hands on browser since I'm not a fan of DOM walking for modern apps. I think ECS browser would be awesome. Oh, ECS browser. What do you mean by ECS browser? And because all I can think of is entity component system. Also, that's a neat term. I think it's called still need. Yeah, this one. I think it's called like a status line. There's like a couple of lines. Status line. There's like status line. What kind of lines do we have? I don't know. I think this is kind of like the tab line. Tab line. Yeah, tab line. It's the one at the top. And this is the status line on the bottom. And I don't remember what it was called. Dual. No. Okay, so we're talking about entity component system. Instead of having a giant tree of elements and styles, why not just use ECS? Obviously, I was really considering when browsers were born, but now it seems like a natural next step to me. Yeah, I've been thinking about it. I think I tried that once. I think, I don't know. I think, okay, here's what I think about web dev, front end, frameworks, how to organize, like how to build a UI basically, how to organize the code so that you get the UI that you want, how to So I think that the things we have right now with React and everything, it just it feels like we haven't reached a sort of obvious perfect framework or perfect way to build UI. It always feels like, because I think that's why also where we get all these different UI frameworks and stuff, because it always feels like something is like amiss. It feels like we're missing something that should be the perfect way to build UIs, and I don't think we're there yet, obviously. And yeah, I don't think, I'm not sure if we even gonna get there though. I think it's also a little bit touching on, the human limitations, human psychology a little bit, because we are the ones that needs to understand how to build it and how to read the code and everything and organize it. So I've been thinking a lot through the years also about building some sort of language that uses tags instead of using like instead of using like identifiers, you use tags instead to get what you need and what you want. So because because basically it's such a nice way to, well, I guess it could be a nice way to get the thing that you want, but also you have that's also a problem. Like you have to have a system within the tags as well to be able to think about it in a nice way. So what I mean is basically, yeah, I need a function here that has this signature basically, and then maybe you can add some tags. So basically, I'm not sure if you're familiar with Hoogle, like Haskell's search engine for searching for functions, because you can basically search for functions that has a certain signature, and you will get probably what you're looking for in that case. But then there's like other information. It's not just the signature that you need to look for. You need to also know there could be other details that you need. But yeah, it is a pretty complicated area, I think. Yeah, UI is tricky, yes. Reducing it down to just things, behaviors, and attributes in code rather than just the idea of something easiest will allow us to. Yeah, maybe. I mean, I'm kind of skeptical because it feels like you need some sort of structure, and I don't know. It just feels like you need it. Yeah. I don't know. It's like I think I tried to do like ECS with UIs. I think one time, and it was like, where do I even like begin? It was the first issue. But yeah. Okay. Sweep Y. So okay. So I think this function is actually called whenever you get a. It's weirdly named here because it implies that it's only for one axis, but we really need it to be both. But here we can see that if we're overlapping X, I think is pretty much what this means. We need to check if we sweep when we sweep Y. So I'm doing two sweeps, I think, and if we're overlapping X, we do this, and if we're overlapping there, we have this. Otherwise, we're overlapping as well. It's nice that I added this comment for myself in the future. Okay. Am I supposed to check in the buffer? No, but this is a function you provide. I got a fairly decent ECS implementation ongoing. Let's see if we can get the URL on top. Oh, nice. I'm just trying to figure out what this is here. Yeah, that's cool. I'm actually interested into if you want to make it if it's public, and I mean, I know this thing works. Let's just see how I'm using it here, because I'm pretty sure that I'm just Yeah, on axis overlap. Oh. Oh, I see. Okay, okay. So basically we're checking if one axis overlaps. Then we also check collision after. Okay, yeah. So we need this function in the quad tree as well then. So we need, yeah, okay. I'm gonna copy this, move to the quad tree. Now it makes sense. And let's see. Yeah, here's the main function. So here's the intersection. So basically, yeah, we are, this is for each entry. We are calling intersecting, which will get us all intersections for this specific entry. And right, so we need to change this somewhere. Here we're checking, right, so orphaned are ones that are like outside the tree, so we don't really need to worry about that. Now we're down, page top down. Co-stream manager, your new in config anywhere, it looks great, keep on. I'm planning to make it public. I just need to fix some things with it first. I'll have a couple of people asking for it, so I will try to make it public as soon as possible. Heck yeah, all my projects are on GitHub. I love building public. Oh, nice, cool. Thank you. I'm gonna check it out after the stream, I think, because I'm a bit interested in the ECS UI part, because I am building, you know, UI stuff as well. And yeah, so let's see, page, wait, actually I want to check this one. Okay, it's done. Object literals. Okay, so do you work now is the question. Okay. File not found. No, it does not work. Okay, so then we say runic report, file not found, error here. Try to fix the runic source code so that we can support this expression thing. All right, let's go back here. And yeah, it's gonna be super nice if that language could work. I mean, I haven't checked against of like bash alternatives, so I don't really know what's out there. I just tried out because I love like languages and you know, different things. So I was just trying to make a Zig-like bash script language here. I'm using AI to actually build it. So slowly but surely. Well, it's not actually slow. It's pretty fast actually, because AI is doing it. So I don't even need to do anything. Although I do think it's fun, but it is working for me here to make this language, and yeah, it's gonna be pretty cool once it's up and running there. All right, so let's see, intersecting for page top down, yes. So here we're checking if we're intersecting with a page. If we're not, then we'll return. I think this is the only place we're doing this, so this is why we have it here. Then we're going through all the entries. These entries are the ones we need to sweep against. This is like the brute force here. So we're going through all the entries in the page, which is the ones, the collision bodies or whatever that's in this page. So, or node, or whatever you want to call it, the quadrant. And so we're just going through all of them and just checking for intersections against all of them. So this is where I want to have a sweeping thing instead. So let's actually, yeah, this is top down and this is bottom up, so it should be here as well. So we should, yeah, this is the same thing here. Actually, first let's intersecting entries in page. I'm gonna put these here instead. So I will copy this, put this here, and up here this is the same thing, kinda. It looks a little bit different, so that's why I wanted to put this like side by side here to see. Okay, so the only thing different is we're checking index. Could be null here, optional. Okay. So here the index is exists and here it's optional. Okay, yeah. The index, man, I forgot about what this meant, but it's something to do with the dynamic thing. Let's make it optional. Oops. What's this weird syntax I've done here? We'll make index optional. Parts are hard, learning my compile dev right now. Yeah, it's fun. It's really fun because you feel like you can do some cool stuff with it. Sweep broad face, then brute force narrow face. Yes, that's what I'm doing. I'm basically, well, I have so the first phase is the quad tree, and then within a quadrant we do so now I'm gonna do a sweep and then brute force at the last part there. Can even go with a verlet approach depending on how much you like the maths. I don't know what that is. Could you can you explain? Let's see, we return, we don't return. Okay. Right, so it's like interesting page. Okay, what else do we need? We need a page. We need self. Allocator. And ABB. Yeah, we need everything, basically. So there we go. All right. And yeah, and so we'll remove this and keep this part, which has the optional handler. And then you, I will also do this. There we go. All right. So now we've centralized the functionality. And now we can focus on this. So this is the brute force part. we want to switch this into a sweep and then brute force. So I'll go over here and I will copy this. All right. So this will be intersecting entries sweep. I'll just call it sweep here. And I'm not sure if we need self. I'm just gonna pass in entries, which is what? That is that. Okay. Oh, well, this should really be its own type. Page entry. Slice of page entries. Now, are you? Hang on. No, this is a like a list. Page entry list. There we go. Ah, we need... No, wait. Okay. So we don't have bodies, we have entries. We need buffers. So I'll just create the buffers here. Sweep line buffer. It's gonna be entries length times 2. And well, it's gonna be whatever this is here. So I need to import sweep from, I think, there. No. Collision. Oh, it's just sweep like that. Okay. Right. So now we have that. So now you need this is gonna be what are these? Indexes. Okay. I'm just gonna say this. I'm just gonna keep it on the stack here. Maybe that's bad, actually. Let's do like we need allocator, so. But that's gonna be like allocations. Yeah, this is bad. I'm gonna put this in the. I'm gonna have them on the struct. Yeah. There we go. So I'm going over here. I'm taking you, moving you to the quad tree itself. No, that's the page. Yeah. And sweep line. There we go. All right, back here. And this is now entries. Okay. So we're doing a little bit of ensure total capacity precise, expand to capacity. So basically, yeah, we're allocating up to that. I wish I could do that in one go. This allocates. Okay, yeah, I think that it's not really a huge issue. This allocates, and then this just sets the length here, yeah, to the capacity. So it's gonna look like the arrays or at the capacity. Okay. Is this correct though? Entries.length times 2. Why is it times 2? Is it because of the 2 axes? Okay, well, whatever. It should work. Alright, so we have these things. Now we need actually this array list, this should be like the unmanaged, no, the managed, no, the unmanaged one. So why do we not need to provide a allocator here? Because we haven't used this function for like an ancient time, as they say. Okay, so we need to provide an allocator, which we don't have yet. So there we go. And you don't need an allocator. I was like, what's happening? Okay, there we go. So now we're building up our buffers. We have the sweep. All right. I was welcome back, Stefan. I was asking what the verlet approach is, because I haven't heard of that before. I don't think. All right, sweep. So this should still be correct. You are now Qt, and then this should be entries, and this should be usize. Right. Usize, this is kind of, I'm using like usize as a identifier for the entities in this context here. Okay. Right. So here's like on axis overlap. We do it now. Now we do a brute force. You could say it's not really, you know, yeah. It's just a collision detection against the other thing. So body A is gonna be entries. Actually, we just need this one. Entries. Entries A. No, hang on. Usize. That's the index. Wait, that's the index of this one, which is not the same. We actually need like the contents of this. I'm not sure if we get that here. Source. Yeah. We just get like the index. Oh, but we can get the index from it though. So let's get like index A is. Wait. We don't get this in the axis over. We should get a reference to this as well. So you should also get the source here. Yeah. There's a neat article here if you want to see implementation. Okay. Vertical integration is just a method of applying Newton's equations of motions. Ah. Interesting. So we're trying to like pre-calculate if something is going to collide or something like that. Let's see. There we go. And then you. Okay, this might actually not work because I'm looking at things here that is weird. But okay, well, I guess we'll see. Okay, this should be the source. And here we should also provide the source. There we go. All right. Good way of getting. Yep, you can determine object trajectory and thus check its stuff in its path. Okay. Good way to get rid of tunneling without substepping. Oh, I see. Right. I see what you're talking about. Like, if something is going really fast, if you have a very thin wall and something's going really fast, they could actually like go through it because the update is just checking the instant position in one specific moment in time. It's not checking like in between. That's cool. Yeah, I don't know. I implemented the substeps just because I was basically following a guide, and it said like, yeah, you can add substeps if the collision detection looks weird. Add substeps and it increases the precision, and it worked. So, well, I had to fiddle around a little bit with it, but yeah, I've been thinking about that issue actually before. I think my solution was basically just, well, I guess it was just to add more substeps, I think. But yeah, that's definitely, you know, better. If nothing is gonna change the equation, you can just use the equation and see and calculate if it's gonna hit. Yeah. And then you can get like collision events in time. You can get the specific time where it happened. Maybe you can even use. Do you need to like go back to that point and then redo everything, because that could change future calculations as well. Like if something collides, then you have like changed the history. May cross AV but has collision result on the wrong side. Yeah. High speed objects can collide like any other. Yeah, that's pretty cool. I've been basically neglecting that though, because basically the way I do it is basically I don't allow anything to be super fast, but yeah, and try not to have very thin collision boxes. Yeah, you can calculate the exact point of collision and thus rewind the object. Yeah, what I'm thinking, like, don't you have to rewind the whole simulation, because other things might depend on that same collision, and you have to like replay from that point with a new trajectory of the entity. But maybe that's too much detail. I don't know. Yeah, okay, so now you should get the source, which is the use size slice. And now we can get the index by using source A. And then this should be index A now. And then over here we get the index B from source B. And body B, or not really body B, it's more like AABBA. Oh, AABBA. Wait, isn't that like a cheat code? AABBB is going to be self entries index B, and then AABBA is going to be wait, what the hell is check collision? Oh yeah, so this is where I have like different types of collisions. I could technically have, you know, a polygon type thing. I did do this, but this is when I was first created the physics system here. But yeah, I'm basically we only have you know, AABBs. So this one is like, I mean, actually this is a collision, so it's more, it's not, oh yeah, we actually need the body. But I think we have like entry values. That should be the body here, body A. Unused capture. What is this? Oh, these are the B's. I see, we don't have a B, we have an I. There we go. Okay. Sweep. And why doesn't this work now? Overlap it. All right. Actually, whatever. We don't really need to initialize capacity there. It's kind of like a, you know, initial optimization, but whatever. Okay. Now we should be, well, actually, we've only implemented the functions. If an object is moving in relation to the rewind object's position should also be rewind. Well, integration can be used for soft body physics too. Okay. Yeah. That's what I was thinking. Like, in order for that to be calculated correctly, you should rewind the whole thing. I guess you don't need to maybe rewind like objects that are, you know, farther away or something like that. Maybe you do actually. It depends on how fast the objects are going and stuff. Like if you shoot a bullet and it's supposed to like ricochet and hit something else, then you do need to like rewind everything. Also, this should be like, you know, if objects are at rest and stuff like that, probably like optimizations you can do there as well. Oftentimes you see like older games with physics when you have things that are just supposed to be lying on a table or something, but they're like wiggling around like crazy. Actually, I haven't thought about a scenario like that. Yeah, because what I'm thinking, like, you shoot a bullet, it ricochets off something, hits something else. If you don't rewind that the thing that this was going to hit, well, I guess it depends on how far the time step is, but this would be, I guess it would be a pretty small time step, I guess. Well, I mean, yeah, it's gonna depend on like frames per second, I guess. So it wouldn't really affect that much, maybe. I don't know. It depends, as I said, it depends on how fast the object is going. Still jitter when you're constantly applying force to stationary object like gravity. Yeah. That is true. You still need to do it because it could be maybe if the surface is like slanted, the object should like have some friction against it and still move down or something like that. But I was just thinking about things that are obviously should be like still, like wheeling around. And there could be some kind of like, I don't know, edge case there where you could like say that, okay, this object is at rest, so stop it. I don't know. Okay, so let's see. No, this is so intersect, entry, sweep. All right, so now we just need to use this function. Oh, also this part here. Actually, we should provide the collision. No, wait. Intersecting entry. Right. This just check there. This checks the entry intersection. Okay, so we should use this one instead, I guess. Actually. Yeah, we just need AABBs. Okay. Change it. I'll change it again here. This one. Let's do ABBA. Actually, I think this is like items. Yeah. And then when we have them both, now we say intersecting entry. Oh, we just need to provide the index for the B there, I think. Yeah. So we're checking if these two intersect. We have an ABB and an entry index. That should be fine. So we don't need to fetch you. We don't need to do that. Not sure what's going on with this left thing here. But I guess it should work since I have it from before. But I won't. Oh, the allocator. I don't think we have an allocator on self. Okay. Why do we need an allocator here? For this. Maybe I should just store the allocator on the quad tree itself. let's see. Yeah, so now I can just say self. Okay, there we go. I won't bother fixing any other like allocator stuff right now. I just want to make this, get this working here for now. So right, so now we need to, now we should, if we call this, it should check one entry. No, wait, it's checking all these entries. Okay, this is a little bit different. We actually want to have one entry checked against these entries using a sweeping algorithm. Sweep actually just checks them all against each other. That's not how I was using this. Actually, okay. But we do want... No, I'm stupid. Yeah, this part. This is where we check against everything else. So instead of doing this loop here, we want to call the sweep with page entries minus, or wait. Wait, we need... I need to make a convenience function here. Slice. And it's const self buffer self 0 to self. Alright. And now we can use slice here instead. There we go. Okay, so what's your issue here? Page entry list. No, so now let's just do usize. There we go. And oh shit. Well, actually, you don't need this to be mutable, so we'll just do this. Wait. Oh no. What the hell? Oh yeah, okay. How are they supposed to know the positions if we just provide like an index? That is very, very true. So I need to change this to, I need to supply some sort of getter function that gets the AABB from, so we have the context, we have the index, and the source, and then we get an ABB. Yes. So instead of doing, yeah, and then you also need this source buffer, yeah, it's unused. Yes, yes. Get ABB. And you also need this. Let's see, and the context. There we go. Yes. Now, get AABB. I guess, okay, I guess we already have the source, so we don't really need this. We just, yeah, okay, so let's do that. But we might need, no, we don't. We just need that. Get ABB source and also context. And then that should be good. Actually, this should be like ABB, get ABB context source. There we go. All right. Now we will change this as well. Remove you. There we go. Why am I not getting like errors here? And you context ABB. And you ABB. And you. There we go. You need context as well. Why am I not getting errors? Oh, here we go. Wait. Expected 7, found 6. Oh yeah, so now we need a get ABB by index. Should return ABB. So get actually get no set entries values index. There we go. No, what? No entries, items. There we go. There we go. Oh, nearly had a heart attack there. Okay, so now it knows how to get the ABBs. And now we get a whole bunch of stuff here. Does not support field access. Oh, wait. How long ago did I... This was like the Rayleigh vectors before. Okay. A lot of things has changed. We now have to do this. I do need to get v. What's the issue now. Found expected quadri into class. Function get AB usage. Usage bowl usage cont. Wait. Source. Ah, there we go. And you, there we go. Okay, all of them are fixed. Now, we can throw away this part. This is the brute force enters check, delete. Now we're doing the sweep check instead. And that's also a problem now. Okay, so we are back to the problem here, because the thing is, we want to check against one entity. That's right. So I wasn't stupid. I was stupid, but also not stupid. But it might turn out that I'm actually stupid as well, because maybe, yeah, because we are looping through. We are like checking for one entity at the same time. We should really be just going through all quadrants and just do a sweep on all of them separately, right? Instead of doing this, like looping through each entity. So basically, okay, let me go back here a little bit, back it up a little bit. So first, where is the thing? Yeah, intersecting. This takes an ABB and produces an intersection check for that. So that's great. However, in this part, populate and intersect, this is like the only function that gets called from the physics system. And its purpose is to build a quad tree, but also report any intersections of any entries in the quad tree. And the way we do that right now is we loop through all entries and insert them one by one into the tree. Then, for like in the same like loop here, we also check for intersections, which means that for that one entry. So it means that when you insert the first entry, we don't have anything else to check against, so that will always, you know, produce no intersections. But it's also going to be very fast because we don't check against anything. And then the next entry we will insert to a tree and then check for intersections. So that you only have one entry to check against, so that's also going to be pretty fast. And so on. But as the tree grows, this is going to be like slower and slower. And I guess the alternative that we're looking at is not doing this, but instead wait until every entry is inserted and then do a sweep check. We go through like each quadrant that has entries and then do a sweep check on those. Because the sweep check is very good at finding collisions between entities, like multiple entities at the same time. So yeah, or we could keep this and then modify the sweep check a little bit. I'm not sure what the best is. Like, is it the best to do this, or is it the best to not do this and then do like a go through every quadrant in the tree and do a sweep check. Actually, then we also need to modify the sweep check a little bit, because we need to check. Sweep check only checks the entities that are in the current quadrant, but there could be sub quadrants with more entries as well. So each quadrant only keeps the entries that are in that node, but there could be like children of that node that has more entries, so it won't check against those, and those might also collide. So I think our easiest way out of this is just to modify the sweeping thing to be able to I'm not sure if this is good for that though, but modify the sweeping thing to see where is it here, to check if this collides with anything and not check everything against everything else. But that might lose the whole. I don't really remember the sweep algorithm, 100%. That might lose its speed a little bit. No, but there should be a way to use, like, to have one. This is sweep for all of the things. Maybe we'll make a separate version that is like for one that you can supply one entry point, like, or one entity that you're supposed to check against instead. Yeah, we'll do that. I'm just gonna check the runic here a little bit. Alright, so this should now work, it says here. We'll see about that. Okay, I haven't gotten like build errors in a while. There we go. Okay, now this syntax works. Awesome. Cool. I want this to work as well. Why is this not working here? Let's tell AI to fix this here. This expression should evaluate to 1 because result of value is equal to 1. Try to fix this in the runic source code so that we can support what do we call, like, accessors, field accessors for struct instantiated structs. All right, cool. Yeah. Now, how would we do this? I'm just gonna try this. So let's just copy this. Put you somewhere over here. Sweep. Sweep. What would this be called? With sweep. sweep 1, but I mean, look, okay, whatever. Okay, we have source. We're gonna have the entry here. Okay. Still need these things. And this will be like sweep 1. Okay. Do we even have a seed tracer yet? Alright. So what do we need to do? So let's check what's happening here. So first we're doing some memory gymnastics here. We are sorting some sweep lines. And what's happening there? So we're going through each of the sources, and I think we're sorting them based on their position in that axis. So we have like 2 axes, we have X and Y, depending on, yeah, so we're basically sorting them by where they are in the axis. Okay, so once we have the sorted things, oh wait, no, we're actually just copying. Okay, so we're just gathering the data here, and then we're sorting here by min value. So now we have the sorted list, and then let's see, overlapping buffer X. Oh, okay, I see. So we're just distributing the slices here, the buffers. We are going through these, and okay, so we're initializing this to false. This should really be like a mem set or something, I don't know. Does it have vectorization? Maybe I shouldn't touch this. Also, does it need to be maybe a mutable slice, mutable pointer array? It may have alignment, may have any element type. Interesting. Yeah, that should be the same thing, I think. Okay. Overlaps X. Yeah, so we're so basically the sweep algorithm is like you sort. So first you sort by, let's say, the X axis. I'm actually sorting by the Y, I think, maybe. No, X. Yeah, I'm sorting by the X axis. I think you can choose, you know, if you want to start with X or Y, because if you're like running if you're running a horizontal game, like I'm doing, like a side scroller, it's probably best to sort by X, because all the things are gonna be more stacked up on the Y-axis than on the X-axis. So you're gonna have a lot of spread on the X-axis, but on the Y-axis most things are gonna be on the same level. So you probably want to sweep on X if you're doing like a vertical shooter or something like that. You want to sweep on the Y-axis first, because then the things there are gonna be, well, I guess it doesn't. Well, I guess it matters less there, but it's just to get a little bit more there. But yeah, anyway, so you're basically sweeping along and seeing which lines are overlapping, or regions they are overlapping, and if they overlap, then you check. Then you can check for Y. If Y overlaps as well, then it's a collision, or then it's an intersection. And then I also have this threshold here that I sweep on Y as well for, I guess, is it only some of them or everything? I don't remember actually. But I do it like 2 sweeps. Or if there's like... yeah, so if we have a number of overlaps, if we have more than 3 overlaps on X, we do a sweep on Y as well. Just to partition things even more. And then we have like this on axis overlap, which is like a hint that you may have a collision here or you may not have an intersection. And so you still need to check, do the last check of checking the entities against each other. But we get a hint of if they actually... we get what you say, we could get false positives, but we never get a false negative. So we basically eliminate a lot of checks by doing this. Okay. Yeah, so the thing is now but this is all if we have just a list of entries that we want to check everything against everything else. Now what we need an entry that we actually only interested in checking this entry here. Okay. And so this entry really needs to be part of this here, maybe. Or maybe not, actually. Sweep lines, min. So what is this, like min? Yeah, we get like the line start and the line end, basically. Min is like the start, max is the end. Oh yeah, it works in a kind of weird way. Like if we encounter a min, that means we've overlapped. Oh yeah, that's right. So this is, it's kind of hard to explain without showing the graphics for this, because yeah. But basically, we keep a counter on how many are currently overlapping in this axis. If we encounter a min, that means we've encountered the start of an entity. If we encounter a max, that means we encounter the end of an entity. So if we encounter first a min, then we know that we are in an entity right now. And then if we encounter a max, that means the entity ended. So now we don't have any more entities here. Or we have more we might have more entities, but this entity has ended. So we decrease this counter here to say that now we're back to 0. Okay, but if we encounter a min, we increase the counter, and then if we don't encounter a max, we encounter a min again. That means some other entity has started their line. So now we know that we have something that overlaps already, or I mean we have an entry already, and now some new entity has started. So now we know that this is overlapping on this axis. And then, yeah, I do a little check here to see if we have more than 3 on the same line, or on the same, like 3 entities that intersects at the same time. We also do a sweep on Y to kind of optimize even further. And but otherwise we just say that, hey, these two, or these 2 entities, which is gonna be the current one we're checking against, and all others that have been there before. So that's what this is here. We have the buffer X and then overlaps X. So it's basically going to be able to check, if it's going to loop over this one and check, okay, which ones are true. Those are the ones that are actually currently like overlapping for this entity. And so now we can check for each one that is true in this one, which are the entities that are before. This is so hard to explain, man. I just feel, but basically, this is a hint that the ones in this list might collide with this one, so we just check against everything there to see if they actually collide. Okay, but that is for, I just need to go through so I can understand it myself. But that is before that is checking everything against everything else. Now we only need to consider this entry here. So I need to think about how to do that now. Here. Okay. So yeah, I just remember now. I just went through this to remember. Yeah, you're enjoying the debug session. Yeah, nice. I just went through this to remember like how the sweeping algorithm works, and now it just clicked for me. I just realized that, okay, I just read the code and I can see how it works. Okay, but how would we do this now? So here we're considering all the previous ones here and this one. Really, we only want to call this, so maybe actually we do want to provide this into the list. I'm just thinking like we could skip ahead because we know the min is, do we have the value? Yes, so we could actually skip ahead already, like over here maybe. We can skip those that are not supposed to be in there. Like if you encounter like a, or maybe we can't. Not in this part, I don't think. No, wait, we can. Everything that has a max that is less than the entry's min should just be discarded, right? Wait, but is this really a sweep algorithm? Like, that we need, I was thinking. Like, okay, I'm gonna do this. I'm gonna fill up my coffee a little bit. I'm gonna check this. Okay, now you're apparently, okay, this still works. This should work now. Okay, there we go. It works. What else do we want to do? Let's go into the features. Optionals. Man, this is a lot of things here happening. Also, the highlighting for the comments doesn't really work. I'll try to manually fix it and tell AI how to fix it, but nothing works. So there's some weird stuff happening with the highlighting system here. You have to have something before for it to work. If it's the only thing there, it doesn't work. Super weird. So I'm not sure what that's gonna be doing here. I'll just start a thing here and I'll refill my coffee and I'll be right back. Oh, hey. Welcome. Well, okay. No, it's not Rust. This is my toy language here that I'm using AI to develop. Yes, I know. I peeked in here because I needed to tell AI to do something. Okay, well, 1 second here. 13. We'll go back to Zig here. I was just about to grab a cup of coffee. 1 second here. Report file not found, error here. Try to fix this in the room. All right. Let's see. What's going on? Okay. Yeah, so we're doing a sweep. Okay, so I'm improving my collision detection thing. So we're currently doing a sweep algorithm. We're trying to have a sweep algorithm. I already have a sweep algorithm, but it works for like a group of entities only to check everything against everything, basically. But now I want to adjust it a little bit, because we want to have this entry, like one entity that we want to check against only in the sweep. So the idea is to modify the thing the sweep here a little bit to support providing only one entity here. Okay. Yes. So. So let's see. I was supposed to like think about this a little bit while I was gone here, but okay. So the sweep algorithm. So I just went through this here a little bit. It's kind of hard to show how it works without, having some sort of graphic or something. But basically the idea is it's a collision detection, or it's not really a collision detection algorithm, but it's kind of aiding you in finding potential candidates for collisions or intersections, I should say. So basically the idea is that you sort the entities in one of the axes, like the x-axis or the y-axis, because I have a 2D game, so I only have two. So I sort them by the axes. And so let's say that one entity, okay, actually you can do this. One entity is over here. It's a 2D game, so they could be on separate, something like this. One entity is over here, and then one entity is over here, and then one entity is over here. So let's start with this. So basically the sweep algorithm is like this. We sort everything by the min. I think it's the min, this is the min. So each entity has a min and a max on this axis. So this is the min, this is the max. So we sort them first by the min. So this will be the first entry, this is the second, this is the third and fourth. They just happen to be this way here. And the way it works is it's gonna check which ones overlap in this axis. So when we start this algorithm, let me move this down here. We have this counter that says that, okay, are we currently do we currently have an entity? Okay, let me start over. So the sweep algorithm is called sweep because you can imagine there's a sweeping line here. There's a sweeping line here, like this. This line is gonna move to the right, and it's gonna encounter this one. It's not actually moving like this, it's not moving like one pixel at a time or something like that. It's actually just jumping to the min here because we're having this list here, but it's just a show here. So we sweep here. So first we enter this one. Okay, so we encounter a min and a max. So basically all of these like min and max points are stored in a list. Both of them. So we store both min and max in a list. So first we encounter this min, and then we encounter this max. So if we counter first a min and then a max, we know that there's nothing else in this
in this axis here. I might have written made this wrong here, X and Y, but whatever. You get the point. So if you first encounter a min and then a max, you know that there's no intersection. Okay, so this is now off the list. Then we go down here and we encounter a min. The next point is actually this one, which is also a min point. So we encounter 2 min points in a row. That now means that we have an intersection, actually, or potentially an intersection. Okay, and then we encounter this max. Okay, that's fine. And then we encounter the max. So now we're out of these two. And then we encounter a min and then a max. So that's how the algorithm works, basically. And also to help us here, we have a counter. So basically when we're down here, we encounter a min, we increase the counter. We encounter a max, we decrease the counter. So if we encounter a min here, we increase the counter. So now the counter is 1. We encounter a min here, we increase the counter is 2. We also check, before we increase the counter, we check here, like if the counter is more than 0, we know that we already have encountered entries. So now this will be an intersection, and we check that. Okay, I'm not sure if that was a good explanation here, but I'm just gonna keep going here. So now the question is how to modify this to work with one entry. That's what I have to think about. Also, 1 second. All right, thank you. Let's see. Christian Christian. Yeah, thank you, Christian and Lobsang for the follow. Okay. Now the thing here is how to do this. Well, as I said, we could just skip the ones that are like before. So we could, like, until we've encountered this min, we don't really care. So let's I think I'm gonna try to put this min into the list maybe. But then that might be bad. Let's do this. Let's do like entry min is gonna be it's just gonna be so entry ABB is gonna be get ABB context, and entry. Okay, now we have our ABB. Now we'll check. This is gonna be left, which is just that one. Actually, we could use that over here actually as well. Instead of doing this, we could do like ABB left and right and bottom. All right. Okay, so that's the min, because now we're in the x-axis first, and then the max is right. Okay. Yo, you're back. Let's see if we can make this work here. Okay, so the idea is here that if we encounter a min, we should keep the same logic, I think. Maybe. Yeah, we do need to, yeah. But we do need to add now a check for this as well. We need to check if we have encountered this one. So I think I just want to have like a bool for that, so like has encountered entry. So I'm just gonna do this in the stupidest way as possible first. And so here I want to check if overlaps x is more than 0 and has encountered entry, then we care about this. We also do the sweep y. I think I'm just gonna skip the sweep y for now, I think. Yeah. And let's see, let's only do this. And we don't really have an entry actually, so on axis overlap will change as well. We don't really have like an entry here. We should still keep these things, I think. I'm not sure about n. What is n actually? Overlaps x. Oh, that's how many entries are actually overlapping. Yes, that's right. Okay. But this one is gonna be the entry. Yes. And then we do need source as well, I think. Yes. Okay. So now instead of passing min index, we're just gonna pass entry here. Okay. And this should still be correct, I think. Yes. Now we also need to do this check here. If entry min is less than this, then this should be true. I'm pretty sure. We also need to check max. So, and entry max is more than that. So we're basically checking this collision here, or on the axis. We have to do it. I'm just thinking if we have to do it every time. I guess it doesn't really matter that much. It's not a huge deal, I don't think. I think probably if we put this over here and then voice crack here. We will check if entry max is less than the max value. That means we're now done. So that means that we should just quit here, actually. Okay. Now, will this work, though, is the question. So we're always checking if this like collides with this min here. If this is less and this is more. I guess equals could also be true. Question mark? Whatever. It's floating values anyway, so. Okay, so min is less than that. So basically, yeah, the entry should collide with this line. That's the only information we need to know that it's colliding. And that's true. We check then. We have to check further for that. Right. We are setting this to true. And then that exits there. Okay, I think this should work. Oh, sorry Zig people. That needs to be and. This is not used, right? So let's just get rid of that. I'll just comment it out for now. Okay, so now we should actually have a sweeping algorithm for one entry only, hopefully. And let's see here now. So intersecting every page, sweep. Yes. Now let's use sweep 1 instead. Right, and you need the entry over here, which is a U size. Whoops. Okay, so you need shoot. Okay, so actually this is like this. It's supposed to be an AABB actually. Okay, well let's just do this. Sweep. Let's call this like sweep by ABB or something like that. Or with or whatever. And then the entry ABB is just entry, so we don't really need to do anything there. We'll get those. And then on axis overlap should be ABB there instead. There we go. All right. Now here, this is entry, so it should be ABB. And we'll put this over there. All right. Okay, now you are ABB. Index, we don't need. You don't need index. Well, you need index, but you don't. There we go. Yes, good. Expected. Okay, yeah, we need to change this now. So A is actually an ABB. Let's just rename this to be ABBA. There we go. All right. Now, I'll just check back here. Unknown function called unknown function. File not found. Oh, still. Okay, wait. I need to run this. No, it's still a thing issue there. Okay, I'll leave this now. What else do we have? Like errors? Flow control. Classify 3. Why does it say like file not found? Alright. Okay, so let's go back to the. So now we're in the game code here. Let's see. Is there anything here that needs to be Okay. And the real issues that needs to be okay. Let's launch and see. Okay, we're gonna crash. Great. Index out of bounds. That looks like a large-ish index. Can't believe you failed. Okay, quad tree 791. Get ABB by index. Right. Actually, is that like an AAAAA number here? Okay, I'm gonna do this. No. Yeah, because I recently learned that in Zig, if you forget to put something, if you have something that is undefined, and then there's an error with that number, the compiler actually puts like this number 0xAA. It fills it with A's depending on the size of the type, and then you can easily see that okay, so it's because of some undefined that's not set or something like that. Okay, so this was this is a sweep. So okay, so this so sweep 2 3 1. So let me go back. No, here sweep. Here source. Okay, so apparently the source is like way off. Maybe it's the no, where am I? Sweep 1. No, it's not sweep 1 and sweep by ABB. Copy sweep lines. So you are and the entries is this. Okay. So what is happening? Is it going over the thing? Alright, we're getting the source. This is the entries here. We have the buffer and everything. So are we using like the length of the thing maybe incorrectly? We're going through the source here. No, it should just access the source directly there. Oops. Oh man, there's a lot of changes. Oh, maybe I forgot to push some other stuff as well. Okay. Where is the part that we are interested in? Nowhere. Huh. Why is it not showing at all? The intersecting line. Okay, whatever. I mean, I guess we have to check. I guess we'll log the entries. So I will do this. If the entry is larger than this, I will log it. Entry is larger. I don't know, man. Entry. Okay, let's go back right here. I mean, all it's gonna do is spit out. Yeah, we got this huge number. I guess it will confirm that we're actually passing in wacko things there. Yeah. Okay, so there's something wrong with where is the thing? Entry. Yeah, there's something wrong with this thing here, or I mean this thing here. So yeah, this thing here. So actually, this is like undefined, this is 0. So really, why would that be so? Where are we creating pages? Oh yeah, that's how you do it. Okay, whatever. This is set to empty. So it should be like undefined length 0. We append this here and a slice. Maybe we'll check this, like if item is larger than, I don't know, max entries times 100. Then we will panic and say yeah, like entry is very large. Unless there's something wrong here. The length is plus equals items length. Yeah, that should be fine. No. Okay. Let's see what's going on. I really should get like debuggers, a debugging proper thing working with this, but yeah, I had so much trouble trying to set it out. Oh, we didn't actually get the panic there. So maybe there's something wrong with like the pointer. Which is weird. Shouldn't be anything wrong with that, as far as I can tell. Like I was thinking like the page pointer. That's the pointer where it's putting the things. This is an array. Like the page isn't being copied or anything like that. It's just a pointer that gets passed around. Interesting. Yeah, because I added a check here. It's already bad over here. I'm pretty sure I did. The page comes from here. The quadrant should be populated as well. Maybe there's something wrong with the initialization. Now we're setting it to empty here. And then we have like quadrants. The quadrants here are all null until they are populated. And where would this end up? This is like the okay. So basically, how this works is I have this add page prepared. So it is a tree-like structure, the quad tree that's in the name. Okay, and we start with the root node. Each page, which I call page here, but node page is the same thing here. So basically, we could have a parent, if we're the root node, we don't have a parent, so that's why it's optional. We have a access align boundary box, and yeah, so all of them have that. We have an offset, which I don't remember. Oh yeah, that's the position, maybe. Where's the index? Oh yeah. Okay. So this is I think this is the index. So that's what I was going to explain. But basically how I set it up is we have a list of pages. How the pages are stored, they're stored in an array. But they also have the tree. So the tree works like you have this page in the array. But then the page itself points to other pages using this structure here. So we have like these 4 quadrants, because it's a quad tree, so we have 4 quadrants, top left, top right, bottom left, bottom right. Now these might not exist, or they might exist as well. If they don't exist, they are null. That means there's nothing in it, in that quadrant. If they're populated, that means there should be at least one entity somewhere in there. So that way we can skip whole quadrants if it's not populated. Okay, and then but then there's like either it's null or it's a pointer to another page, and that page of course has to exist in the array, the page array, because that's where all the pages are put. And what I was thinking is that maybe something is weird with the quadrant initialization or something like that. It's weird though, because this code should have worked before, but that's usually the case. So we add a page prepare. What I was thinking, like, when do we actually add like the quadrants? We are adding them actually in here. So here is like we go through each. So basically this is like where we actually build the tree. And so we're going through all the entities that we want to insert into the tree. So we're going through each one of them, and we insert the entry into the tree, and we get out the parent of that entity, so the page where the entity ended up in. So this could be any quadrant in any layer, in any level of the tree. It could be deep down, it could be the root node, it could be anything. So so then we also have a map from entries to pages, so we can easily get to the page where the entry is in from outside. And yeah, so yeah. So my idea was that maybe somewhere in here we insert into the page. This is just setting up like z-trace, like performance checks zones. We have the root, and then we try to insert into the root some more zones. We check if this contains. If it doesn't, then we return null. If the current page contains the entry. Otherwise, we will insert into page skip boundary check. Yeah, a lot of deeply nested function calls here, but and then here we insert into quadrants. If that fails, because if it succeeds, we get a page out, a parent page. But if it fails, we do an or else, because then it's like null. We do so basically either you are put into one of the children, or if you can't find a node that can accommodate the entry, we have to accommodate in the page that we are in right now. And so yeah, and that can also fail if the page has, because each page has maximum of 10 entries as well. So if you have more than 10 entries, you can't get into the page. So that will also result into null. And ultimately, if you have too many entries, then you would end up as an orphan, or you would probably create a new quadrant somewhere. Well, actually, maybe you don't. No, if the entities are like larger, Yeah, there's a limit to how many entries you can store actually in the quad tree, as how I've built it here. So then we insert into quadrants, and we check here. We get the quadrants so these subdivisions are basically not the quadrants themselves, but they describe the boundary boxes of the quadrants, so we can check for collisions against each quadrant for the page. So we're going through all of those subdivisions, and we're checking if they contain the entry, and then if they do, we check if we need to create this quadrant. If we do, we actually populate this quadrant with the add page prepare. That's right. Okay. I'm also going through this for myself because I need to refresh on how this works a little bit in order to fix this issue here. All right. Okay, I'll just check on this a little bit here. Inline. Okay, it works. Cool. I just want to get this. So this works. What? Structure flow control. So all this works. So now we have if, else, if, else. Okay. Cool. And do you work? Invalid let binding. Okay, let me do this one. True trues. This is weird. Is this like a command? True? Is that a thing? Yeah. Okay. So that was why I was weirded out here. So we're piping true into true. That's weird. Okay, this is all AI generated here. So I'm just gonna say the runic produces, runic produces a found not found error on this line. Try to fix the runic source code so we don't get this. Well, so okay, so we can support this expression. There we go. Now back to the thing. All right. Page. Like, I don't think there's anything wrong here. And that's the ABB of the page itself. And the parent. Okay, let's where was the sweep? Let's check. Okay, let's add this back here for entries E if E is a U size, right? Yeah. If this is more than like 1,000, I'm gonna log that E is more than 1,000. Okay, just to have something to search for later. Okay, so we do that. Then we also want to log. How did you do hex? It was like X and I want to put. Oh, we don't get the page here. I guess entries.pointer should be like. Should maybe be. I'm gonna check that pointer, and then you have to do like int from pointer. Okay, let's check this. Yeah, at some point I need to fix the so I can run debugger here and just go through, because then you can just step through everything and see instead of trying to you know, put logs everywhere. Well, the pointers doesn't seem to be like an undefined pointer. I mean, it might very well be. I will also log out the index here, just so we can see. Oops. If it's like ridiculous. No. Here. So are you still here, Zaflins? Or is anyone like a Zig programmer here? Yeah. How do you feel? How much have you looked at Zig? Okay, so it looks reasonable here, except for the actual index. Wait, am I looking at the correct thing? Yeah, this is supposed to be a use size. Maybe I'm doing the. Maybe this is. Maybe it's not actually that. Am I? But apparently this never exceeds like 1,000, so it should be correct. Looking into implementing 2D lighting, I've seen a little bit, not much, mainly from tease, adding clips or web images. Okay, learning. Yeah, 2D lighting. I've also looked a little bit at 2D lighting actually, coincidentally, because I think I wanna try. I wanna mixture a little bit with lighting in the game. Not sure if it's gonna make it in there, but yeah, we'll see. Linear algebra. There we go. Algebra. Linear algebra right now. So this seems like a perfect way to test my knowledge. Just make vector math. All right, cool. Yeah, I saw a very nice video. I saved it in my playlist, like Gamedev playlist. 1 second here. Yeah, I don't know if this could be good. I'll just share this. No, not the list. I don't want to show the list. Wait, hang on. There we go. that one. Pretty cool. I haven't really done anything with it, but I was just. It's just a nice like inspiration and could be, you know, useful. Because I just saw the, you know, it might be, I don't know if how your graphics gonna be, but you know, I like the 8-bit like large pixels, and so that kind of aesthetic was like perfect for me, and so I thought that the lighting looked really cool in that video. All right. Okay. I don't think we gain much insight into what is actually wrong here. It just spits out randomly that weird random numbers. And I don't understand why. Yeah, I'm trying to figure it out. Let's see. I mean, really, we could just put the page in here directly as well. Let's just put the page here. I'll do this. Whoa, what the hell is going on? Now, sometimes when you accidentally hit like the Windows button plus a bunch of other buttons, you never know what's gonna happen. Entries, page, entries, slice. Yeah. Well, it might have to do with that I'm trying to make my own list thing here, but whatever. It shouldn't be that complicated, really. Okay, let's just see, and then the thing here. Let's see. So if this is true, I also want to do page pointer. What else could we look at in the page to see? We could look at the AABB maybe. I'm gonna also look at the quadrants. So we'll do like X, 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 X. This would be like page quadrants. Top left. Oh. Sorry. No. This could be null. Okay, I'm just gonna do this. Okay, so now we should get more information maybe. We'll see. They're hoping that the page might be, I mean, it doesn't make sense to me, but the page might be, you know, the null value or undefined or something like that. I don't know. Wait, what's happening? Oh, ambiguous format. Why am I okay? Oh yeah, that's right. So we have a formatting function for you. So there we go. We Windows. You never know what's gonna happen. Yeah. Oh no, do I have to update the format function? Oh. Yeah, this is because SIG has updated the version, so I have to go to its shape. Now I think we don't get this and this, which is good because I didn't use it anyway. There we go. Question mark? Have you any experience with C? Well, I never actually like made a project in C, but I know a lot about C, and you know, I've seen a lot of C code. And I was self-taught in C++ long ago, so you could say I have a lot of adjacent experience with it, but never actually done anything like in C. I did read the source code of malloc at one point to understand what's happening. And I've dealt with calling, you know, syscalls and reading the... Because I was into like the assembly at one point, and so I did a little reading on the like the Linux source code, the syscalls and stuff. How long have you been working on the game? I started last year sometime. I don't actually remember, but about a year, you could say. Let's see. No, this seems fine, I think. Maybe? Yeah, the ABB actually does look correct as well. It's just the entries that's messed up for some reason. And I think, I mean, it could be because it's a array. It's an array that is like copied. Maybe. I have had problems with that in the past. Let's figure this out. So we'll go back to here. Okay. Add page prepared. You actually return a pointer. Here we're setting page to this. You are empty. And that's fine. The length here is set to 0. So that should be set to 0. It doesn't matter what the... This is just undefined anyway, so it doesn't matter. Because what I'm thinking is maybe we copy this somewhere and that's where the problem is. Actually, that is where the problem is. Oh, wait. Or is it? But this is a slice. Shouldn't this be correct? This should be like... Oh, wait. This needs to be a pointer. It could be a constant pointer, but it's a... yeah. I think that's the issue here. Oh my god, okay. Oh. Wow. I'm pretty sure this is the issue. We're gonna get a bunch of logs here and maybe get some lag, but yeah, there we go. Okay. Oh. Okay. Okay, I'm relieved and annoyed at the same time, but yeah, okay. Where are we? here. Okay, let's go back. And this. Right. So, okay. So if I just go through what happened here, it's basically when you do this, sometimes I think SIG has like this thing where sometimes it passes it by reference, sometimes it passes it by copy. It depends on something, I don't know, but you can't count on it, you know. And since this includes an array, SIG doesn't actually copy the contents of the array. It only copies. I don't know what it copies. It copies like normal stuff like this. That's not things that are not arrays. It copies pointers. You know, the pointer address. You know, if you have a pointer, it copies the pointer address, but it doesn't copy. It doesn't copy the contents of the array. So that's why we got this weird error here. But if you change this to, whoops, a pointer, now we're dealing with the original page entry list, which still has the content that it should have, and now it works. Okay. It's just that whenever you're dealing with arrays in structs, you have to be very careful when you're like copying them around. That is okay, and that's a note for me because I usually get into that sort of error. I just need to thank you, Zig, for reminding me about this issue. Okay. Right. Wait, what if I remove this autofix? Will it still be a warning or something? No, okay, fine. Finally. Okay, cool. Now we're okay. Finally remove that annoying thing. Okay. Now, what have we done now? So what we've done is we have where are we here? Quad tree. So what we've done is that we have this quad tree, and we're checking for collisions within the tree to check which entities collide with each other. And before you had one entry you wanted to check against everything else in the tree. And so what it does is it looks for which quadrant is colliding with it, and so on. And then you get to each way down, you have to check against all other entries in each quadrant. But we are dividing the space, so you get way less checks unless comparing to a brute force algorithm. But when you get down to the last part where you have to check against other entities in the same quadrant, then we did a brute force check. And then if you had like a lot of entities in the same quadrant, that became an issue. And it could be solved in other ways. I could like not have a bunch of entities in the same quadrant. But let's just see if this works. So what I did was I implemented a sweeping algorithm for doing the last check here. So hopefully that is like faster than the brute force check at the last point. So we have now a quad tree at the top level. So each time we do a collision detection, we do a quad tree check to get the entries we check against. We do a sweep to check against those. Actually, I just thought of something. Maybe we should just compile a list of entries. Okay, anyway, and then the last part is the brute force against after the sweep. So now, before we just had quadrant, or quad tree and then brute force. Now we have quad tree, sweep, and then brute force. So we inserted a sweep in there. Okay, now let's check for how this works. Must happen of course maintaining a PS pure structure of arrays ECS. I can show you how the physics system works soon here, because it's kind of interesting. Wait, what the hell happened? Oh, I was accidentally going through there. I was like, oh wait, no, what happened? Okay, the physics system is broken now, so great. Why does it work like for the bottom one? Great. Well, it doesn't really work. Oh man. Interesting. Might be the min-max filtering, ignoring those high tasks. Yeah, maybe. Also, I'm concerned about the FPS. It's pretty jumping all over the place there. It felt like it was lagging a little bit. I'm not sure. Did I forget some kind of log? No, I don't think so. Okay. Okay. Yeah. We'll try your. Yeah, I'll try to look. It sounds plausible. I'll try. Let's see. Yeah, the filtering. Yeah, I mean, it's obviously something is way off. Okay. I'll just do this one. Oops. True. Still. Okay, wait. I have to do this. Or not. No, it's still the same issue. So try again. All right. Anyway, min and max. This should be like world coordinates. Everything should be in world coordinates. So that's good. So if our entry is less than this, actually it should be like max, less than max. Does this even mean anything though? It doesn't have to be min. That's the thing as well. It doesn't have to be less than min actually. No, it doesn't have to be less than min. But max has to be more, that's certain, that's for sure. Maybe we should check like if max... Yeah, we should definitely have this. If max is less than min, we should abort, we should return. Yeah, then we're done. Otherwise, we have not actually encountered max yet, so we can check if entry min is is it less than we have encountered? Yeah, I think so. I think this could be the thing. How? Yeah. All right. Let's check this. Railib's GPU accelerates. I'm assuming plus Y is up the screen. I don't actually remember. No, it's still okay. It's lagging even more now. This is going great. Yeah, this should be true. Like if we're already over, if entry max is less than min value, that means we've already passed that entry, so we should exit. Right? But otherwise, if min is less than this, we have encountered the entry. And if we have any other overlaps at this point, we should check those and so on. Here, if we encounter a max, this is the end of one entity. We're checking if max is also done. We should return. And we also deregister this here. I don't see why this shouldn't work. But obviously I'm missing something. And the value, is that stored correctly, or? Because I don't think we were actually using that before. I'm not sure actually. Yeah, the value. X-axis is X, then we do left on min and right on that. Yeah, and is this work? Does this work properly? Index B is source of I. I'm gonna check if that's correct. I mean, I don't like it's lagging insanely much, but that might just be that there's some very inefficient. I mean, that means that this part here is very inefficient here. Probably. We could actually move this out here because both of them have like value. No, actually, no. I might just move it back to brute force and look up some kind of algorithm for checking one ABB against something else. Hello, Polaris7. Have a nice day yourself. Thank you. Wish I had some experience with Zig. Looks like a fun fix. Yeah, I love it. I love Zig, and I really, you know, at first the syntax was kind of a little bit alien, but I've actually learned or grown to love the syntax, and a lot of things just make sense to me now. Like there is some logic to it. There is some inconsistencies at certain parts. But I think for the most part, things make a lot of sense. And yeah, I really like it. The physics code apart from of your ZG program. Yes. I can show you here because I need to boil this a little bit in my head here in the meantime. So I can show here the... Let's see, where is this thing here? Container. Yeah. So basically, this is the struct that has every like position and velocity and everything like that. The rotations part is not implemented because I didn't need it for this game, but what we do have is like positions, velocity, acceleration, and then a flag here for basically if you are affected by, I think, gravity or not. I think I don't remember exactly, but I think that's what it means. So basically these are vector array. This is my own like thing here, but the only reason why I have those is because Zig does not allow for like variable length arrays or vectors. Okay, so a vector in Zig is just like, it's an array basically, so it's just an array, but it's automatically vectorized when compiled. So it's using SIMD instructions. And you can do things like you know, plus minus. Let's see where we do this here. Where's the thing? Okay, I have this function integrate. Where's the thing? So here, here's an example. Here we have like, these are pointers here, but why is it pointers? I guess it's because I need to change them. Anyway, so this is a vector. You can see here, at vector, this is a vector type. So it's basically just an array with this number of elements and this type here. And you can use arithmetic operations on the vectors, and this will compile into SIMD instructions for if it's supported and everything like that. But yeah, so it's very fast updating whatever thing you have here. And basically what this function is doing is we take one array and then another array, and then adds takes the first array and modifies it by adding the second array here. And then we also have a you know, delta time component here that will scale it, so you also can take multiplied by this yeah, as we call it, a splat. I'm not sure how to pronounce this, but it's basically just we take a scalar and makes it into an array or a vector of the same size as the array you're looking at here. So this whole thing becomes the SIMD instructions for like adding B and and scaling it with that. Okay, and this is, bear in mind, this is almost like this is one of the first things that I wrote in Zig, so take this with a huge grain of salt here. But this function, I don't remember what it's doing here. I think I tried to be a little bit functional here. So I'm passing like a function. Okay, you can pass like a function, a pointer that takes that does something with 2 vectors basically. And okay, so I should go through these things. The array list itself, the vector array list. So how it works is that I have a list of vectors, because first I choose what is a good size of the vector, like how many elements is good to have in one vector. So let's say it's like 512 or 2048 elements, like floats or whatever, in one vector. But then what if you have more entities than that? What if you have 5,000 entities? Well, then I just keep an array list of these vectors here, and if I need more entities, like places to put the position basically, for example, I can just extend this list with another vector. So then I'm basically increasing the capacity of how many elements I can store here. So it's kind of a list of lists, or a list of vectors in this case. And then I have a bunch of convenience function for actually like creating this this thing here. And let's see. Linked list. I mean, I guess one of the reasons why I wanted it to be that like array list is that the actual elements will be stored together. So yeah, so they will be stored like their location in memory will be very close, or they will be adjacent basically. If you have a linked list, that works as well. I mean, it's probably not a huge deal, but yeah, then you would have to do like a jump at some point. But yeah, it's just to optimize the space or the caching there, I guess. Yeah, so basically then we have all those vectors, and then we run this update positions. First thing we do is this, set runtime safety to false, and this will like disable checks like I guess, you know, overflow checks and a whole bunch of stuff that's to do with yeah, doing stuff. I'm not sure how much it actually affects this thing here. I just set it to false because you know, it should be faster. So and then we do each one here, each component by itself. I really should remove rotation because I don't really have rotation, or maybe make a version of it that doesn't do anything with rotation. So but the whole thing, this function actually, it's one of the updates in the physics system that takes like the least amount of time to run, and for my game. So the most the collision system is the thing that takes most time. So what we're doing is basically taking each one here. So what this means is basically this is modified to be added by this, and then also we scale the modification with dt, with delta time, and then vector, you know, velocity y is added to by acceleration y. So it's doing like SIMD operation on each component like this. Yeah, and that's it. Basically, we also apply gravity at some point. Gravity is applied, but that's only applied at one point. So what that is doing is just changing the acceleration. It's just setting the acceleration to some kind of gravity vector here. Yeah. So yeah, that's just like adding, we're just adding gravity into acceleration. And then also this is a way to kind of disable gravity for specific entities. So if an entity has dynamic set to 1, this will be, you know, the gravity. If it's set to 0, it means the gravity is basically disabled here. And I guess you can also modify it to be like 0 point whatever if you want to modify the gravity for a specific entity as well. But yeah, that works pretty good. And it's a little bit busy in here, like different syntax stuff, but yeah, it works. And I haven't have to gone back here in, you know, since I made it, so it works pretty good. And yeah, that's basically that's the position part of the, or the, you know, position, velocity, acceleration, and gravity part of the physics engine. And then of course this is called like 8 times per frame. So but I've seen in the traces, I've seen that this takes about I don't know, 10% of the time each sub-step, something like that, or even less maybe. I'm just throwing out a number here. I haven't actually looked at the percentage, but just through the visual blocks of when I'm seeing the traces. Yeah, thank you. Yeah, so it's all in the magic of, you know, SimD and stuff here, and the vectors for. So basically, what I had to do is just build this framework for doing all this, and then this struct here was a major part in solving the issues that I had, because the vectors. As I said, the vectors, they can't change length, so they are like an array that can. Well, arrays in SIG also can't change their length, so you cannot like just have one vector that you can allocate to a larger vector. You have to like have this list of vectors that I have here, or maybe there's some other way to do it that I don't know about, but this is basically how I solved it here. So, and then I also mixtured around with how many elements in each vector is a good like what is it? Yeah, just the optimal number, and I don't know. I just threw out some number. I mixtured a little bit here, and so vector size. This is how large in bytes, I think, or bits. Yeah, and then I just divide it by the size of the float, and then we get the number of elements here. So I basically mixture. I don't know why I did it like this, but I basically just mixed around with, and it seemed like this works good. I don't know if it depends on, you know, your number of elements or something like that, but this seemed to be pretty good. I don't know, 512 bytes. Yeah, maybe that's better. But this is really not the like, you know, it's not really the bottleneck right now. But it works pretty well. So I'm not gonna have like 100,000 entities or something, but I've run some tests, and it does break down at some point, but like 150,000 on my computer, which is not really that many though. But I don't think I ran the trace to see where the bottleneck was, but it might have been something else that was the bottleneck. But because you know, you've heard of things like people have like millions of stuff. One thing that I will say though is that this is not multi-threaded. This is single-threaded. So, you know, this could potentially further be improved. Also, maybe you could also use what is it? You know, GPU or something to calculate the stuff. because that's like it's just a static. Each substep is a static system, so you're just calculating the new positions, and that could be heavily parallelized. So a GPU would be a good fit for that. Anyway, that is how that works. Now back to this one. Okay, so yeah. Also only real down single thread graphic stuff. Yeah, I mean it's the easiest way. I've never really been big on threads, like multi-threaded stuff, but this seems like a good candidate for it if you really want to optimize the thing. And you probably want to spool up some threads in like the start of the program or something, and then have them like calculate these things in parallel. Because you could just divide up the like by index or something, and yeah, maybe each vector array in one thread. But that only really helps if you have like more than I don't know, 1,000 entities or something like that. Because SIMD is doing a lot of work. So I'm not sure if you even get more performance. But for the collision part, that's where you could probably do a lot of improvements with multi-threading. That's actually a path that I want to go down, but not this stream though. Yeah, this problem here is okay. Let's just do this. Let's say we have this entry. Let's say like over here, and then we have one go over there. We have like one over here. One starts there and ends there. One starts there and ends over there, or something like this. I don't know, let's do this. So basically, first we should be here, and then min is less than the min. No, it's not. The entry, so this min is not less than this. So we haven't encountered entry yet. And then we reach the max there, we reach the min there, nothing really happens. The max is not less either, so there we go. Now becomes the interesting part here. So we encounter this min, now we have an entry in the list. We encounter this min, now this is true, so we have encountered this entry here. Oh, I see what's happening. We're missing stuff. We're missing this one. We're missing because the sweeping algorithm actually optimizes a little bit. So if you encounter this one, you only check against this. Like the previous ones there. We don't actually check against this. Ah, okay. Okay, yeah, so this diagram, yeah, I should explain. So basically, this is the scene, X and Y, and this part is the entity that we're checking against. And then here are all the other entities. So this is an entity, 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 and this is an entity. So what we're interested in the sweeping algorithm is the min and max points in the axis, in the x-axis here. So here's all of the left, these ones are the min points of these entities, and all of the right ones are the max points of the entities. And what the sweeping algorithm does is it takes all the min and max. We're gonna ignore this one because this one is not part of the original algorithm here. Or it takes all the points here, min and max points, it marks them as being min or max, and also stores, we're using the value here as well. And then we sort it by the value. So that means that we get a list where the first element is this one, because this is the leftmost one, and then we get this one, and then this one, and then this one, and then we get this one. This is all in the list here. And then, so how it works is basically, let's take this first one as an example here. So first off, nothing has happened yet. We're sweeping from the left to the right. So first we encounter this one. Okay, that's a min, right? But since we haven't encountered anything else, what we do is we have this counter that we increase by 1. And I also have this bookkeeping thing here where I set this to true just to know which index it is to identify it later. But this counter increases by 1. Okay? Then we encounter a max. Okay, so now we're on the max. And here we check, or here we just say that, okay, now this has ended, this entity, and we decrease the counter. So this is how many are currently overlapping here. So when we get to this one, we still have, this still is 0, the overlapping counter is 0. But we increase it by 1. And then here we decrease it again. So now we're outside. Here though, here's a different situation here. So now we encounter this one. This is a min, so we increase the counter by 1. Now we encounter this one, and this is also a min. So when you encounter min again, this is now positive. This is like 1 now. So we know that we have this entity which hasn't ended yet, right? And we encounter another entity, then we know that they are actually overlapping now. And when you encounter something that overlaps, you run additional check to check if they it runs actually. You check against every other entity that is currently started but has not ended yet. And so that is every entity that you have encountered min, but not the end yet. So if you haven't had another one, let's say this one also was, this one also was here. First you encounter this, and then you encounter this. So now you have 2 things you have encountered, and then you encounter this. So when this happens, we actually check against both of these previous elements or entities that hasn't ended yet. And then this one ends, so this one is done. Then this one ends, so this one is done. And then this one ends, and this one is done. And then this one starts, but there's nothing else that has started yet, so nothing happens. And then this one ends, so nothing happens. That's how it works. Oh, I'm understanding what you're trying to do. So you want to construct an ordered list of entities where the key to sort is the min x, so that you have a list of smallest x to largest x. Now it's both min and max. This is the min x, and this is the max x of each entity. So this is one entity, where this is the min x of the entity, this is the max x of the entity. So this is in order to keep track of which entities are still on the sweeping line, you could say. It's way easier, by the way, if you look at some kind of animation to show algorithm, because it's not that difficult to understand when you see it like animated. I'm trying to run like explain with these little squigglies here. Maybe it's better if I do this, I don't know, to kind of see that they are the same entity, I don't know, but it's combinatorial, I don't know. I just know how the algorithm works. You keep track of the min and max. So you're only interested in the x-axis sweep. You're only interested in the x-axis. And you can choose if you want to do it x or y-axis depending on, you know, optimization on what would be better for your situation. But in my game, x-axis should be the better choice because most things are aligned on the y-axis, so we're just checking which ones on the x-axis are colliding or not. From my understanding, if you're checking just 32 entities, you'll be checking each of them against each other, meaning that's... No, so the sweep actually... So, well, okay. The sweep will check... it will turn each entity into 2 points, the min and max, right? And it will only check each point once. So that means that it's like an O of n times 2, or 2n. And then plus, you know, a little bit of setup and stuff. We have the sorting. We have like the sorting algorithm as well. So, you know, you could technically say that we add a little bit something there. But it's like 2 plus n, or 2n is the actual, that like this algorithm here. Is because you're only checking these points. You don't check everything against everything else. You just check these points. And you keep track of how many overlaps you have and which entities are currently overlapping at any point in this sweep. But what you get is not a full you don't get the actual intersections, you know. What you get is candidates. So these might collide. These two might collide here, but they also might not collide. We know that they collide. We know that they collide in the x-axis. That's what you get. So you get all the entities that are colliding in the x-axis, and then you have to do the rest of the check yourself. But it does cut off a lot of checks. So, yeah, so that's like how the normal like sweeping algorithm works. But what I'm trying to do here is I'm trying to say that, okay, we have one entity that we're actually interested in, and we don't actually want to check everything against everything. We want to check just this one. Is this one intersecting with anything here? So that is what I want to, that is what I'm trying to do here. And I'm trying to like fit this algorithm to actually work with this. But I think I know what the issue is. And that is because this is not like part of this list. So we have to kind of wing this in by doing these kind of weird if statements here. But the problem is here, like, this is encountered, okay, nothing else was, this is all like history, it's all zeroed out, so it doesn't matter what this is. At this point we don't have any overlaps. Now we have one, and so after this point we have one, and then here, well, actually let's say that we encounter this one first. So we encountered this one. Now we know that No, actually, that's actually, let's just move this one over here. There we go. So let's say we encounter this one now, because we're not. This is not included in the set, so we are encountering this one. Now we can see that, okay, this one actually is now encountered. So, but we're only checking against this one now, because that's how the usual sweep algorithm works. We're not actually checking against this one. So that's what we need to do. So we're basically okay. I think that the problem is we have to check against both of them. And then once we've done that, we can mark them off as well, I think. Because we don't need them anymore. So I will move this up here. Yes. And then after this is done, I will set you to false. And we might be able to optimize this even further. And we could no, let's keep that there. I was thinking of like erasing this and these from this, but I think we'll keep this here. The most important part is this. Setting this to true will say that, okay, this index is now overlapping. If we then clear it here, that means we don't call this function again next time. Like, let's say we have another one starting over here. So when we encounter this one, this is still part of the result. So when we encounter this, we don't need to check this anymore, because we're already, we've already collided with it before. I'm not sure how much sense I'm making here, but I think this could solve the issue here. Yes. I'm just trying to go through all the scenarios in my head here. So yeah, we're setting it. So at this point, we're setting, but we have set both of them to true. Right. We encounter. So now we see that, okay, this is less than this. So we know that this is now encountered. However, there's an issue also. This scenario here, like if we have this one over here, for example. Let's just get rid of the rest of the things. If we have this example, first we encounter this min. That means we have this is entered into the result. Then we encounter this. Now the max is actually less than this. So we just quit. That's an issue. We don't ever check against this now. So I think the best way would be if this is actually part of the set instead. Or we could somehow... No, yeah, I think it should be part of the set. Might I suggest defining a space in which collision detection is run, and then just use quadrant to gather entities from the quadrant span by the entity being checked. I'm assuming the first implementation is something like for all entities and detectors or something. It's defining a space in which collision detection is run. And then just use a quadrant to gather entities. Yeah, I mean, that's basically what I'm... okay. So how it works is this. First, yeah, so this is physics stuff. So the first thing that happens is basically we're updating positions. this is like this is like a substep. Physics substep, let's call it. Physics substep. So we update positions. That's the thing you saw before. Then we do a collision detection. And then we resolve the collisions. Which means that you could, you know, bump into things and blocking and actually changing like position and velocity and everything like that. But the collision detection, first we build the quad tree from the entries, and we also check each we check okay, this is entirely true because this kind of happens at the same time. We're building the quad tree and we're checking intersections. So so if I show the quad tree here and we'll go to populate and intersect. So this is what happens here. First we get this is where you build you check the collisions. This is an entire thing checking collisions, well, in the quad tree. So first we go through all entities, we insert them into the tree, well, one by one. And so we insert the first one here. Let's say we're on the first entry. We insert it. Then we check for intersections at the same time. So this means that for the first entity that gets inserted, it's gonna check against only one entity at this point. So there's a very fast, you know, check. It just checks. It doesn't collide against anything else because it's the only entity. So it doesn't. Nothing happens basically. Then the second entity comes in. It gets inserted. So now you might have a possibility of those two colliding with each other. So we're checking against intersections for that entity against everything else in the tree. Now the tree only has one entity in it. Well, it actually has two, but it doesn't count itself, obviously. So, but yeah, so it's like a, you know, a little bit of optimization here to make sure that we don't do like double, you know, checks against other entities. Because if we, let's say we added all the entities first, then looped again to check all entities, intersections of all entities, then now each entity has to check against a lot more targets, and there's gonna be a whole bunch of like double checks as well. So this is how that works right now. And yeah, and this of course this intersection check also involves, you know, going through the quadrants, you know, eliminating a lot of quadrants based on what you're colliding with and stuff like that. So so yeah, let's see. Yeah, so basically these two things, they happen at the same time, you could say. And then we do resolve collisions. But the thing is that I was thinking about at the start of this stream is that these checking of collisions, that we do have things like collision groups, but they don't play a role in this part. So this part actually checks everything against everything. But here the groups play a part to actually resolve collisions. Yeah. But what I was thinking, like, if we could get groups, somehow partitioning the quad tree in separate groups and somehow do that, we might be able to decrease the number of checks even further. That was my first thought, but it feels like a big task. And I was thinking, like, maybe we could improve the last, like, brute force part, like when you check one entity against other entities in one quadrant, that's where we do a brute force. And if there's like 30 entries there, and each one needs to check against each other. That's like 900 checks just in that quadrant. So yeah, that's what I was thinking, like, okay, maybe we can improve that with a sweeping algorithm. And so we do a sweep instead of checking each one against each other. And that makes me think that maybe the path that I'm going down right now is probably bad. I probably want to redo the algorithm to go through each quadrant and do a sweep check. But that also has other issues. So right now we're like doing things entity by entity. But what I was thinking instead is do a sweep check in each quadrant. But that's the issue there, is that you might have child, like each quadrant does not include every entity that might be in that area. You have children, like child quadrants that has other entities in them, that might have other entities in them, and you don't do a sweep check against those. So that's the problem there. Yeah, so the thing is that I'm not sure if this sweep algorithm is like gonna be better, but we'll see. But yeah, this part here is gonna be an issue. I think we actually have to put the entry actually in the list as well, and then maybe even mark that with a special thing there. So if I'm gonna make a copy of this one, and then I will I don't know what to call this really, but I will just do that. We'll have the entry here, and or by entry, I guess. No, actually, this is not. This is the ABB, I think. No. That was the thing. Sweep by ABB, we get an ABB, yeah. So basically, yeah. So we need to change this to be a by ABB, and value, and then is entry, I don't know. So if it's the entry, that means it's special, basically. There might be a way better way to do this, but whatever. I'm gonna do it this way and see how it works. So now you should be like by ABB. Okay, and we need to pass the entry there. So we should get yeah, that needs to change. We also need to change where we call this from, but I'm gonna fix this here a little bit. I mean, we could just append. No, we don't actually. And now you also need to have a special index source entry. It feels very stupid how I'm doing this, but I'll just do it in the most stupid way first, and then we'll see how we can improve maybe. So this is like by ABB. And then, but the problem is like, okay, how would we know if it's the entry here? We're going through the source. Now we just append it by the end, I guess. Yeah, we don't really need... Actually, I'm gonna remove this one. And we're gonna get... Oh, shit. I mean, we're really just producing a sweep line here. That's... right? We're producing 2, I guess. Okay. I'll just make a copy and... ABB. Wait. We could also just have an index. Okay, let's forget about this. Yeah. Forget about this. Now, this one should still be there. Yeah. We don't have these. No, we don't have you. Yeah. We don't have this. We just pass an index to tell. Okay, this is a special one. Yeah. This is stupid. Okay. The entry. Okay. So so we do this, and then we just append the entry at the end. Okay. So so now the buffer is gonna be like source len times 2. That's right, because we have 2 points for each entry. And then no, that's the thing. This is for the min of entry, so this is gonna be like I'm gonna get that this is source length times 2 min max. Yeah, that should be fine. And then this is like this, and then plus 2 and that. And I will change you to entry. Wait. There we go. So now we basically appended this to the end there. I could have just refactored this to, you know, put an A, B in here instead, and yeah, but whatever. Let's just do it like this for now. And then, actually, I want to do it right now. So instead of a source, we are gonna get, yeah, because the source, we don't really use the source other than to get the ABB. So we can just provide ABB instead. We don't need this. We don't need this. Yeah, there we go. And now we don't need to do this. We don't need to do this. We can just say copy sweep line, axis, and the index is that, and the ABB is the entry, and the buffer, and the context. Yeah, and here we can remove that, we can remove you, and yeah. Actually, here we get the ABB from get ABB context and the source. And I don't think we need the context here actually either. No. No. So let's remove that. this and that. There we go. Okay, just so we don't like make some weird mistakes here. Okay, cool. So yes, now we should have everything that we need in here. One thing that we do need to fix though is this buffer now needs to be, we need to add 2 here. So this needs to be like +2. I'll just do it here as well to be sure. Okay. Now, okay, now we should have the entity that we're concerned about in here as well. So now we shouldn't miss anything when doing the sweep. Okay, so we're sorting them by the min value, which is kind of, you know, confusing because it's min value, but it just means it's not, we're not sorting by the min point contra the max point. We're sorting all points together, both min and max, by their minimum value. So by their minimum x value in the x-axis. So yeah, and we don't use the y thing. So now we don't need this, I don't think. Well, we will see. And also we don't need, well, these 2 we don't need, because now we have the thing in this list here instead. Okay, so how do we want to do this now? Let's just, yeah, I don't think this is where we do this actually. It's when we encounter max, and if the index actually, we should have 2 indices here, but if, so line index, if line index is equal to entry min, or line index equal to entry max. No, that doesn't make sense. It should just be the entry max. Yeah, because then we know that this is the max thing. But how would we even know this? Like, we're just using this to sort. We don't really know. So actually maybe we do need to embed this information in here. Oh, okay. Okay, so we do need this. Yeah. Yeah. Alright, I'm gonna copy you by a b. And you're gonna say that if you're the entry or not. Okay. Now we don't need an index there. And I mean, there might be some other clever way to actually get the index somehow, but yeah. You need to be copied as well. And I'm also gonna then say is entry isable, and we just need to provide this here. There we go. and actually this is by ABB. Okay. Now, yeah, we need to change you as well. And we need to go all the way back here to you, and you are now by ABB. There we go. Okay, are we done with that now? So, not really. So here we also need to then provide... No, we need to call this to start with. And then after ABB, we need to say if this is the entry, this is false. And here the entry is true. So the last one is the entry. Now, now we should have a sorted list. We should know which one is the actual entry, which means that for max, if we are the entry, we should just return. Because if we ended the thing that we actually want to check, then we just return. Okay. Then then we want to do what? So let's not have this here. Well, we might need it actually, but we don't. So let's go back to the original algorithm here. And this one we don't do anything. Okay, so now we're back to the original algorithm, except for this part here. But basically, it's like we don't want to do this because we don't care about the other things that might overlap each other. The only thing we care about is the entry itself. And so yeah, we do need this bookkeeping here. Has encountered or is entry overlapping? False. Here we're gonna check if min is entry, then this is true. Okay, so now we encounter the min. Now we can start checking here. So if we are overlapping, then we want to start checking against the other stuff. Now what? Okay, this takes care of when we actually reach the entry at the min point. Now what is gonna happen when other entities also overlap after that? Well, what we want to do is, I think we want to disable after, so because we're only concerned with the entry, so we can actually say that we've kind of consumed the things that we have already ran the check for here. So we're consuming them, first of all. Second is that, let's say we've encountered a thing and then we get to something that is not the entry. Also here, if this is the entry, we don't actually want to do this part here. So yeah, if this is not the entry, we will do this. But if it is, actually, let's do this. If this is the entry, we do a continue here. Because if this is the entry, we don't want to set this to true. We don't care about this, because when the entry ends, it's gonna return anyway. This is like, okay, it's gonna say that, okay, you're actually colliding with the entry. Yeah, this doesn't matter for the entry, I don't think. And then here, yeah, we need to check if we are actually currently overlapping, and if this one is overlapping. Okay, so what happens if this is not the entry now, but it's still if we're still on the entry? Well, it's gonna say that the entry is now overlapping something. So I think what we need to do is, in that case, we need to set this to true first in order to include it in the result. So if this is the case, so it's basically going to be like this. If we're not the entry, we want to set this to true right away here. And also, yeah, and increase that. I'm not 100% on this, because this basically is used here to know how many in this buffer we are overlapping with, but I'm not sure if you have too many overlaps, if it's gonna break something. Okay, so man, there's so much stuff to keep track of here. Which is often the case when you do this kind of specialized thing here. So min is entry, yes, and then we do the overlap check. We consume that. That's fine. Let's go through this. So we encounter this. This is true. We have something overlapping. Or actually, if we don't have, let's do that. If we don't have overlapping, we just go here and go on. Then we encounter min again. It's not entry, but entry now overlapping. So, but then we actually go down here. I think we actually, you know what? We probably want to do this, actually. So if we're the entry, we just set this and then check if there's anything else overlapping. We overlap with that, consume it. But let's start from the beginning. Like, let's say we encounter this. There's no overlap, so it won't go in anywhere else. The only thing changing is this true. Then we encounter something else on min. We set this to true. Overlap is now +1. This is true. We are going to check for those, consume this. Then we go to the next one. We might have another min, then same thing happens. And the old one is not consumed, so we won't actually go into the old one. However, the old one should probably be removed then from this. Yeah. But there's an issue with this though. The issue is that if we encounter a max, that's gonna be, now this is not synced here. This is not synced. Because we've already consumed this index here. I think what we could do, we could check if this is true. Then we do this. But if it's false, then it means that we already consumed it. So we don't need to, you know, modify this. But if it's true, that means it needs to just be put away. The only way we're getting here, I think, is if we encounter the entity before the actual entry here. I am pretty sure. Because then we get min is not an entry, so we increase here. This won't happen. Then we have a max with the same entry, so we're checking, okay, are you existing? Yes, you are. Okay, then we remove you. If the min is entry, we just set this. This isn't moved. This doesn't happen. We encounter another min. We increase. But now we actually consume it. And then let's say we encounter the max of that entry. It's not the entry here, so we will continue here. Now this is actually false, so we don't actually do anything here. Yeah, that should work. All right. Now it's not, you know, I don't think, I'm not sure if this is actually gonna improve performance, but we'll see. If it doesn't, then I have to look at something else, but yeah. Okay, min value. You have to have a separate function for this one. Unless we do any type here. There we go. No. Doesn't that work? I don't know what I was trying to. Why doesn't that work? Can I cast it? No. I don't know. I mean, we could. No. Okay, what you could do, if you want to be super fancy here, you could do like min value, comp time t type, turn a, not a type, but a function. No, function void tt, cool. Return struct min value void t cool, and then we do this, and okay, so now we can now we can remove, or I mean, yeah, produce anything there. Okay, so now we can say that and say whatever we need to say here by ABB. Now it should work. No. Oh, it doesn't have a what? Oh, the self is wrong here. There we go. There we go. All right. Cool. And if you want to be even more fancy, you can also provide like a constant pointer to a function that takes T returns some kind of value. I don't know, F32, I guess. Wait, pointer to constant, yeah. And then wait, this is the get value function. And now we call that instead that. Okay. Super unnecessary, but I just wanted to I like to do some kind of, you know, programming gymnastics a little bit. Okay. And I do enjoy some comp time stuff. There we go. So now actually, also what you could do, you can remove this and call this min value instead. All right, if you want, I don't know. How's it do? How are you doing, Blue? Okay, enough dilly-dallying here. Let's see if this works now. So I'll go back to. Actually, let me just do this here so we don't waste time. Normalize. Okay. Oh, it passed. Okay, cool. So now this works. Great. What else could we do? Optionals. Did this work? No. Look at this cool thing here. And basically, wait. Was it final found? Yes. So let me run on that. There we go. Oops. Wait. Yeah. No, that's fine. Okay, let's see if this works better. Oh, well, that's not promising. No, still the same issue, and it lags as man. wait. I know what the issue is. I haven't compiled. I need to compile here. Oh my god, was this the issue from before as well? Let's see. Because the editor doesn't compile. It doesn't compile the game anymore. It did. I used to do it, but oh, and now we get a crash, of course, instead. Yeah. Okay. No, that's not the error. Index out of bounds. What? Sweep. Oh. Wait. Sweep 284. That is out of bounds. Yes, okay. So, 1 second here. The buffer is supposed to be times 2 plus 2. It said like out of bounds a lot, actually, like 16. The hell? 16? Why? Why is that? Why? Actually, 16, so 253. Yeah, it's this one here. Oh. The index is not times 2. Okay. There we go. It's supposed to be just the... Yeah, okay. Right, so now we go back here, we do a compile. Now, let's see. Nope. We're crashing for some reason again. Alright, let's see. I'll fix this and then that we'll have to do this stream here. Let's see. Where are we? Here we are. Index 3, length 3. Okay, are we adding 1? No? Okay, if we have 2 entities, it should be 4. No, if we have 1 entity, it should be 1 plus... No, it should be 2 plus 2, so we should have 4 length. How can we cannot end up with length 3. I don't understand how. How can it be length 3? It should be like minimum 4. If this is 1, this is 2 plus 2, this is 4. If this is 0, this would just be 2. How can this become 3? Is this a complex equation? Or length? I mean, this is an integer, so it's not like it's 0.5. Okay, wait, hang on. Sweep? Okay, 151. Maybe it's another... Okay, it's another thing. Okay. I jumped the gun a little bit. It's this one. Overlapping buffer X. Oh, wait. I just realized something here. We shouldn't do this if the current is min entity and min entry. If is entry, we will continue. Okay. Yeah, because if we're min entry, we had never increased this at the start. We never set this anyway. However, this might also be an issue here, maybe. No, that should be fine. The index, though, the index should be correct. Yeah, I think the most important part is if we're dealing with the entry, we don't really do anything with the index here, because it's gonna be weird. Alright, I think that's good enough. I said for like the 100th time. Still doing stuff. Where are we? No, yeah, you're done. Now let's see. There we go. Okay. Well, it's accurate, it seems like, but it's way more laggy. Yeah. All right. Okay, that increased the FPS by a lot, actually. Just those two. I don't know. It's just when I get down to the ground here, maybe. It's like when I get up here, it feels smoother. Yeah. Maybe. I don't know. Okay, let's see if this significantly changes. It's because I'm moving or something. I don't know. It's like I'm harnessing. I'm gathering like FPS energy while standing still. As soon as I move, it goes down. If I stand still over here, does it go up? No. It's actually just decreasing. Holy crap. And there it goes up. Okay, this is very weird behavior. Okay, if I open this. Okay, it's actually way laggier than before. Okay. Well, we know now that that was not a good thing. So pretty sure it's probably due to how like we're doing this. Like the sweep algorithm is fine. There's nothing wrong with the sweep algorithm. There might be something wrong with my implementation here, but this is like a special sweep that takes into account one entry. We also like adding a bunch of branches and stuff. I don't know, but the sweep, this sweep is really fast. This is like you know, a lot faster than the normal like brute force. So if we could incorporate that somehow in the quad tree, that could be good. But yeah, I'm gonna do this. I'm gonna go intersect the entries. I'm gonna make a separate one that is going to be just brute force, which just goes through entries and we will get the ABB by index. Yeah. And then this just returns this, yeah. And then we say well, now I think we just do this one. Oh, let's see, we just do that actually. There we go. And oh, yeah. All right, so well, actually we don't need this if we have it on self, I guess. And same thing here. Okay. So now instead of doing this, we will do self brute force. I just want to show the difference here because it's pretty. a lot, actually. Okay. Are we done? Okay. Bottleneck is surely a number of upscaling relations on number of entities. Yeah. I'm assuming you only rebuild the quad tree when things move, so if that's the case, that explains drop them. There maybe, I don't remember if I have that optimization. Then I would have to like keep track of, well, I guess if the accelerations are all 0, then you would know that, but I'm not sure if I actually do that. I do build a quad tree every frame, but then there's also like the sub steps where I do reinserts, so it might have something to do with that, but I'm not sure. Okay, well, now we're back to brute. Now we're back to the original. You can see the FPS is it's different. So I don't know what the hell happened with the sweeping there, but for some reason it's, you know, very incredibly awfully slow, and I have no idea why. So good, also physics. But this still should lag. Like if I go and remove this, we know that this lags, so yeah, if I move this up here and we open this up, this lags a lot. This lags just about as much, I would say, which is like kind of weird because it's just like 30 gems that spawns, and so I don't know. Well, okay. Well, that turned out to be a whole bunch of nothing. But it's a, you know, now we've explored that route and it didn't really work. There might be something really off with the implementation. I mean, something is up. Something is really weird with this implementation here. So also, do you, if the current capacity is less, this function modified array, okay, yeah. So I was thinking if it's like, if it like resizes, but this just ensures that we have capacity. So basically I was checking like, okay, do we do an allocation now every substep here, or what's happening? Yeah, I'm actually, yeah, I'm surprised that it was this this much lag with that. I'm very surprised, but I guess it's also a little bit, maybe because we're doing sweep on a bunch of smaller lists of entities. Maybe we could only employ sweeping if it's like more than, if the okay, wait a minute, let's get the entries out. Entries, let's check if the length is more than, I don't know, 10 or equal, maybe. Then we do the sweep. Otherwise we do the brute force. Do you need okay, no. Okay. We might be cooking, as they say. because yeah, it might be really inefficient if you just have like a couple of entities, but then the more entities you have, the more efficient it will be, compared to the brute force algorithm. Okay, I was concerned there for a little bit. You can see we have a good amount of FPS. It jumps a lot. It goes from like 2000 to 300 sometimes. Kind of weird jumping that much. It's not really great because then you won't be certain if it's gonna keep it on a high FPS for long, and then in which situations will it actually go down. So this is the big moment here. Let's open up. No. Okay, so it doesn't really help. It should help a little bit. Like the sweeping, like if you can see here, like here's the left part of this entity. So it's gonna like start a sweep there, and then it encounters this one. So now those two are overlapping, so they will report a collision there. There might be something wrong. There might be something like maybe there's like double reportings, or I don't know. But it shouldn't. It feels like it shouldn't be this laggy though. There's like, okay, there's a threshold here for sure. Look at this. Like the difference is insane. There's also another thing that I remembered that but before that, I'm just gonna check this here. All right, found not found. Okay, tries to execute. Oh, that's a huge thing here. Okay, so you couldn't find out why. But the current state does not facilitate for conditionals at all. Okay, well do it then. What's this? What kind of developer is this? Like, yeah, it doesn't seem like this is supported. Well, implement it then. Let me falls back to run command pipeline, which okay. So if you like to pursue this further, next we'd like to begin from docs plan from the parser. Extend the semantic type checking layers and finally say. So you didn't do anything? Or what? No. Oh my god. Okay, I'll do this, and then we open like task. And then I will run you. And 16 is that one. Oh, it's this one, okay. So I will copy that. Running runic with this, with this command. Runic tests features. Wait, I think it's optionals. Yeah. We get this error. 1 second here. Okay. No. Okay. This is then the result of the AI doing some investigation on this. Please continue the work. Yes. Okay, so then we do please execute the task described in this document. There we go. Man, these developers, they just don't know how to be autonomous. Okay, so let's see. All this hand holding, man. What did we do? Oh yeah, I wanted to check. There is something happening in here. I'll check if we have some here, like max entries in pages 10. There might be a case of some of these gems actually leaking out into the orphan. So I think what I want to do is, if something gets orphaned, I want to log it out. I just want to check that first. So I'm gonna log this. Actually, maybe not here. I go to the physics system. Where's the update function here? Yeah, and so down here we should still have the quad tree, so we'll do like self collision container, oops, tree, and then there's a list orphaned entries. It's so nice also in Zig that you don't have to worry about, you know, private fields or stuff, useless things like that. You can just access the data immediately. You don't have to go through some weird, you don't have to patch the program in order to access the data. I don't know, it's just something with it that's just, yeah, it's really nice actually. Okay, so orphan entries, that is, yeah, I just want to check the length here. So orphaned entries, all right. Okay, we'll do a test here. And F7. Yeah, I have to go soon-ish. Maybe half an hour. Okay, so no, let's keep that open. Go to editor. It does lag like a little bit at first. Well, now it's lagging more because of the logs. And then, oh yeah, so I need to remove the save file so I can open the chest again. Okay, open the chests. Okay, so we're lagging, of course. And now we should get like Orphans. Right, so, okay. Orphan entries is 25, 26, 14. Wait. Do we have orphans? Okay, 59 is... So what this means is that the orphans... This is kind of weird as well, because 59 is way more than I thought. I thought it would be like no orphans, actually. We could change this if we allow more entries in each page. Orphan entries are really, really bad because they are brute forced. So every orphan... Okay, it's even worse because like every entity that is checked is also like brute force checked against the orphans. So it's not just the orphans that are brute force checked against each other. It's also like everything else is also checked against the orphans, because the orphans might, you know, they might collide. Let's say you have an entity that has an area that's larger than the boundary of the entire root node. Then that also like collides with everything. But anyway, this explains a lot, I think, actually. So so we would have gotten bad results how we, you know, even whatever. Okay, so let's go to this, and I will actually try to fix this by the quad tree. Yeah, max entries in page. We could increase this. To something like 30, I don't know. Yeah. Just so you don't get these weird orphans that's not supposed to be there. Let's just see if this works, because I don't know, I don't remember if I had like any hard-coded references to number 10. Maybe I could just check. Actually, 10. Yeah, this is like intersections, maximum intersections. Well, no, that's the capacity. It can increase. It's like the initial intersection capacity, but then it can increase. What is this? You know, magic numbers. Okay, this is only 10 though, but oh wait, this is the one I just did. Okay, but that's fine. I know what it means. Okay. Yeah, okay, so let's start there. Are you done? Yes, everything went well. The FPS is like jumping like crazy. I don't really like that. It's so weird. I'm gonna do a test now. Well, do I open the chest or not? Let's just open the chest. Yeah, it still lags, unfortunately. But I do want to check now what the number of orphans are. Hang on. Okay, so we do have way less orphans, actually. That's good. I mean, 14 is a lot, though. It might be like the ground, some of the ground, maybe. Why do we have like 14 orphans?
Yeah, that's strange. Okay, well,
it did improve a little bit. But okay. Okay, I'm gonna try this now as well. What if we... Whoops. What if we just... oh. Do this. And... compile. And...
okay, to be honest, I don't actually remember what I just did. Yeah, I disabled the sweeping, yeah. And now you see the FPS doesn't jump anymore. So there's something horribly wrong with the sweeping algorithm that I don't know what. Yeah, it's insane actually. Yeah, the sweep, like this part is happening in each substep. This and also, you know, it's also happening for each entity. So it's basically this sweep is, yeah, it's like each entity we. If we have entries in a page. Okay, if the entity collides with a page and the page has entries in it and the entries are more than 10 or equal to 10, then we do a sweep on those entities against this one entity. The broad face meant to filter out the ends before the hot loop. Yeah, but that's the quad tree part. Like we're space partitioning. So the idea is that I space partitioned in the quad tree part. Or are you suggesting? Oh my god. Are you suggesting to do a sweep? Partitioning the different groups maybe into quad trees? So basically you would sweep, and then each time you had a group of entities. No, but I mean, then you could just do another sweep. That would probably be faster. So the idea of if you only have a sweep algorithm, you would do a sweep, and then all the groups of entities that are like colliding with each other, you would do a brute force on them. I mean, I think, yeah, that's how I used it first. It is really fast. It's like, it's incredible algorithm for its simplicity. Like if you compare it to quad tree, it's like, you know, the sweep algorithm is like 100 lines of code, if even that. The quad tree is like huge complexity. But the sweep algorithm is super fast. It's like, it's so good for its size. It's like incredible. If I was only using the sweep algorithm, actually, I could try and just switch to that, to be honest. Like I could, because I'm using, I can just switch to the sweep. But now I have to update some stuff here. This is gonna be
Okay, so this is allocator. And then I just need to put this here. Don't we have allocator here? Wait, what? Okay, back up. I'm pretty sure I had allocator. I mean, there might be a way to get it. What? Oh, we have the registry, I think, yeah. Singletons, get const, allocator. There we go. So there's the allocator, okay. Okay, anyway. There we go. And then you want what? Get AB, alright. Plus. No, you want that, which is a rigid body, and then you return AV, return attribute. Alright. What else do we do? This one takes, right, that takes the source, which is a list of rigid bodies. I'm pretty sure, but we don't use it because we don't need it. So we'll do that. And you are not needed as well. Actually, no, yeah, that's fine. But const, oh yeah, const. There we go. But now we have issues here. Copy sweep line. Oh yeah, that's right. There we go. And axis index. Oh yeah, the type. We don't need the type. Min value T. No. Sweep line value. Copy sweep line. Right. Oops. Sweep line. Sweep line. There we go. Okay, that's it for that. Watch this be like incredibly performant, and I should just use this now. And they just forget about the whole quad tree. Because I've been putting so much time into the quad tree and optimizing it and having ideas about it and everything. And just the sweep algorithm, it's just so simple and it just works so well. Well, I've been hyping it up now, so it should work. Oh, it crashed. Sweep outside of his substep. I wonder if his substep. Oh, we have AB sweep. I don't think that's. I'm not sure if that is related. To be honest, like, I'm not sure. Yeah, for the tile maps, it's gonna be a lot easier if I just had some of that. But I never done anything like that, so I did it like this. What the hell is this? Reached unreachable code. Why are you going into the quad tree? Wait. Sweep quad. No, collision container. Do we have to change this as well? Oh wait, did I not? No, because I'm not using the collision container. Hang on. Yeah, we're doing sweep. This. If it's R3, yes. Okay, update collisions with container. Fine, it's actually. This is the problem here. Okay, the quad tree. Okay, I totally forgot about this. Sorry. The quad tree is also used. It's not only used for the initial, collision detection thing, but it's also used to put. You could have like an arbitrary rectangle, and say that, okay, hey, find me any entities that are inside this rectangle. Then the quad tree is super good at finding entities really fast. And every frame, we have this quad tree that is, optimized to find something within a rectangle. So that's why I'm using it as well. But it's if it's only for like collision detection stuff, then I mean, if it's only for like the major collision detection stuff, getting all entities against each other, then maybe the sweep is like better. I mean, it certainly is less complex, but the quad tree does help with that. So if I'm doing sweep, I wouldn't even know where to begin to actually just use the sweeping algorithm to find collision. Now we could do this. We could build a quad tree, but then use a sweep algorithm to actually check for those initial conditions, but then have the quad tree available for in the game logic that will actually want to see, okay, if something is in this rectangle or something like that. I can share a snippet of what I've got working in Python on Discord, which I translate it to SIG. Okay, cool. Yeah, thanks. I don't have time to do it right now, but yeah, I saw you enter here. Yeah, I'll certainly check it out and perhaps do something next time. But I'll just make sure that this runs here first and see. I think I put it back to quad tree actually. Yeah, I've been on quad tree for too long, so everything is like in grade now with this, and checking for rectangles colliding with anything in the quad tree is optimized for that. So yeah, that's unfortunately how it is. I do remember distinctly that opening a chest with 30 gems in it though did not actually lag before, so something has happened to make it actually lag. But maybe I'm also looking at it from, I don't know, rose tinted glasses or something, because yeah, I think it's the sweep. The sweep needs to be improved or go. The sweep in the quad tree. Yeah, this part here, this needs to go. There we go. that just messes things up. I need to like think about this, how to fix this better. I think the solution would be to try to get collision groups working with the quad tree. It's gonna complicate things even more, but I'm gonna try one thing first. I'm gonna try to update. No, where's the thing? I also forgot about a bunch of things that I needed to put down here, but this is gonna be like yeah, so optimize quad tree or collision. I'm just gonna say collision system to not lag when opening a chest of 30 gems. Okay, and then we have a solution suggestion, which would be like incorporate collision groups in the quad tree, or perhaps make multiple quad trees, one for each group, and that will make it so that we can check. So if you have an entity that has collision enabled for other groups, you can just go to those groups' quad trees and check for intersections against those. But yeah, it's going to be a major experiment there. Cool. Share with you my fixed grid, dual grid for chunking implementation. Okay, nice, thanks. So that is for the timers. I think that will help a lot for the tile maps specifically. But then there's still the issue that I think this is like a separate issue, like spawning 30 things in the same location is suddenly super laggy. So yeah, I would have to think about that. Maybe, I don't know. We'll see. Okay, so I was just thinking about, because there was a couple of things that I forgot to put down here. No, I don't know. Okay, yeah, but that's gonna be it for this time. So I'll just check this one. Oh, it's done. Okay, cool. So so yeah, thank you very much for watching, and I'll just check if this works now. Does it work? No, it doesn't. It's still the same issue. Oh, but I have to run the thing. I've been so invested in this here because I think it's pretty cool. Yeah, it doesn't work. Okay, well, anyway, that's gonna be it for this time. So thank you very much for watching, and I'll see you later. And yeah.